the reason that I had made that comment on that mailing list in the first place was because I was playing through some old games from the Nintendo Entertainment System, and I was playing them on an emulator. And emulators,
Right.
even in that era, had added the ability to like fast checkpoint. So you could kind of just like, you basically could rewind. I don't remember if the emulator that I was playing had literal rewind, but it had the ability to just like wail on a button as often as you wanted to just save your state. So every time you like walked into a room of something, you could just save. And I was like, you know, for playing through these games, that's actually a lot more satisfying because it's like I can control how much replay I have to do of this game. And it just made it a more pleasant experience to like experience the game, honestly. So that was why I even posted it. That was it.
Casey, you're clearly outing yourself as not a real gamer right now. Because obviously real gamers would never
save scummer. Casey outed himself
coming right there so bad.
Well, not really, because the most
video or just
the
let
most
it go.
nerdy. I mean,
It's so
I'm saying
weird
this is a
setup.
joke, obviously, but like the
Such a
most
weird setup.
people who sink the most time into games are like the tool-assisted speedrun guys.
I was
which like that is not fun at all. But they also produce the absolute most hardcore speedrun of a game that you will ever see. Right?
That's true.
So
I was just on my.
One thing about the stand-up is that I always feel like I have no idea where the conversation's gonna go, and I'm still waiting for them to touch on the Sinking Star game, and I don't know. I don't want to have the same questions as they have, so I want to watch that video in case of people that were joining the second interview after this one, not to have the double one. Let's see.
Way to tool assisted speedrun, guys. Like
I
I wasn't save scumming,
but then
I was
unfortunately
just-
got hit by a build system he wrote for C. It just never quite got the tool assisted.
I don't see the problem. It's fine. So, anyway,
So that's actually good because that kind of leads into one of the first questions I was hoping we could talk about. Like, because I know a decent amount about sort of how you got started thinking about Braid and a little bit to The Witness. I'm interested to know sort of like how did you get into thinking of the idea of your upcoming game? And like we'll get there, of course, but like obviously we want to talk about your language and like making an engine and a bunch of other stuff there too. So I'm interested to hear like when those decision points happened, when you're like, I think it's time to just write a new language for this game.
It's other way around, I think.
It's time to write a new game for this awesome language, is what you're trying to say?
A little bit.
Well, yeah. I mean, the idea for the language came before I decided what game to use it on, for sure. I don't know which order should I answer these questions in.
Let's start with what motivated you for order, because the big thing is that we're just going to go to very technical. So it's very good so that most people that are listening can have a chance to understand more about you and your decision-making process, and then we can get into the fun stuff.
So we're going to talk about the design idea and stuff.
Yeah.
Okay, so, usually...
Honestly, I feel like John is not going to be on time, but we are scheduled for in an hour. So let's see.
Every time I finish a game, it leaves me with interesting ideas to do in a follow-up game. But the follow-up game usually is really different from the previous game, because that's just how it, like, if you start with the actual idea that you want to do, then different forms of game mechanics or structure or whatever might do that idea better. Whereas I think a lot of the game industry likes to do sequels just because it's safe commercially and all that. But I've like literally never done a sequel. So in The Witness, it's this game that came out in 2016, so quite a while ago. And the way the game starts is you see these puzzles. They're like little iPad screens mounted in the world really weirdly. And you can trace lines on them, and there's little symbols like in these grids and stuff. And you don't know what the symbols mean. Like, and the game doesn't tell you. And you figure out what they mean just by experimenting. And
Wolverine, hello. Thank you. Internet, please.
Being an intelligent puzzle player, you slowly build up this idea of what these symbols mean. And then at some point, there's curveballs like, oh, wait, there's a surprise where it does kind of mean what I thought, but there's something deeper about the way this puzzle symbol works. And that's sort of one of the fun things about the game. So I really like that part of that game and that design process. And so after I was done, I was just really interested in this idea. So when I'm designing the symbols, right? At first I was just like, what are some interesting rules that I could attach to these symbols that would make interesting puzzles? But then as I charted out the game ahead of time in my head before building it, I'm like, okay, the interesting part is going to be when we make these combinations puzzles with the symbols coming together. And so we want them to come together and generate surprise. So like one example, not to spoil too much of The Witness, is like, okay, there's these little, I just thought of them as go stones initially, but they're like rounded rectangles, and you have like black and white stones in the beginning, and you're just trying to group them with the line. And then eventually there's multicolors, and you're like, oh, this could apply to any color. And then when there's other symbols, the color of the other symbol matters. And it's not just grouping those things, it's grouping them with anything of that color. So your idea of the rule like expands over the course of the game, let's say. Okay, so I just became very interested in this, idea that what game designers do in some sense, for any kind of game, not even just puzzle games, is they come up with these rules, but the rules aren't just like, there are fundamental things that the rules have to do. Like if they result in a broken game that doesn't run, that's not playable, right? If they result in a very boring game that you don't want to play, that's really bad. But then, you know, at some point, like a good game is,
And if for me the video doesn't load, for you it doesn't load as well, no?
you know, at some point, like a good game is when the rules are designed that they create emergent complex situations out of simple beginnings. And the reason that works is because the simple initial ideas is what can go in your mind and you can understand and can be communicated to you effectively. But then the surprise and the revealing of new things is what keeps you playing, because you haven't seen everything yet. There could be more that you could get out of this experience, right? And the thing that I realized about that, though, so there's other, this is not just my idea about game design. So there was a very famous, I think it was like Kim Swift at GDC talking about how they designed Portal or something. And they do this thing where they put a spreadsheet and they say like, here's all the object types, and you could put an X in the spreadsheet cell. I'm bringing it back to stand-up style, right? So you got spreadsheets. You put an X in the spreadsheet cell when objects interact with each other's type, and then you want that spreadsheet to be like full of X's or whatever, right?
Interesting.
That's an oversimplified way of talking about it, but you could imagine that, right? So the thing is, game designers don't actually know why that works, okay? So it's like, we can come up with rules and design them so that they'll interact, but like why do they actually interact? Like, what's the engine in the universe that makes things interact and generate complexity, right? And this is something that you see in mathematics. So, you know, if you look at like the Mandelbrot set or something, any kind of fractal, you have a very simple equation that when iterated blows out.
Who remembers the question? Be honest.
Into enormous complexity that you didn't expect there. Or like Stephen Wolfram stuff, he has all these very simple cellular automata, right? So there's something about the universe that does that, and game designers don't actually make that happen, right? It's like we're exploiting an underlying phenomenon about reality that we don't stop to think about anymore because we're too busy actually making games. So I wanted to make a game that was about looking at that very closely, and part of that was like, okay, instead of starting with these simple puzzle symbols, what if the ingredients in the soup that we're going to mix together are themselves games that are already fun and complete by themselves? And then we'll mix those together and they'll blow up into like a big, like hyper reality with way more dimensions than you would usually get. So here's the other thing. If you're designing a game, you know, at first you just have some idea and it's usually not as good as you thought. It's like not as fun as you thought or whatever. And so you implement the idea and then you start adding sophistication to it, or like, oh, this thing happens that I don't like. Let's change the rules to disincentivize that or whatever. And at some point you iterate on that enough to where it's fun, or you lose out on the game development. But assuming you succeed, you get to the point where it's fun, and then you ship the game because it was so hard to get there that's basically all you could do, right? And so what happens is games sort of have converged at a certain level of complexity of game design, right? Because the process of making them is always iterating up till you reach that, and then shipping it. And so this was also a way of trying to force ourselves up.
So I'm gonna interview Jonathan Blow right after this interview. So it happened that they are one after another. So we're doing live warm-up and stalking friends over the stand-up. And Jonathan is gonna come over for another interview over here after this one. And I hope that there will be a live Q&A. We'll submit the link when you can post your questions. But we have tons of stuff to talk about, and let's see how this goes. But the plan is to have live Q&A at the end.
Above that ceiling that everybody hits about how complex is the game in terms of the amount of interactivity, because we're starting with things that were already in that zone and then mashing them together and having, I don't know, it's like if you have a vector and you do the outer product with another vector, you get a square matrix, right, for the math people. And then you could outer product another vector and you get a cube, and then you get like a 4-dimensional thing. And so we have kind of this 4-dimensional space of games interacting with each other. So that was the idea.
And that's like you don't have to give any spoilers, but that's like the 4 different kind of like lands that we see in the trailer and everything. And each one, so like the idea is, if I'm understanding correctly, each of the like 4 islands, I think you called them or something like that, right, is like its own, it could be its own game effectively.
It is its own game. In fact. When you start playing them, they're completely separate from each other, and they have separate characters, separate stories, and separate game mechanics, right? And then later on, we show this in the trailer, so it's not that big of a spoiler, but later on, some dimensional combination things happen, and the games then come together, and you start playing with the magic mirror from this game, with like the monsters from this game or whatever. And
this seems that the game will be super complex, long, and I'm super hyped. If this is going to be like an equivalent of 4 games in a Baba Is You style, and then you combine the puzzles in each of the mechanics in each of them for like the special puzzles, wow.
And you see how those rules play out, and yeah, that's the fun part. Or really, the whole game is the fun part, but yeah.
So I wanted to throw one thing in here just because to the extent that I have anything to contribute to this podcast, it's like digging into the back catalog that some people might not know about. Would you say it's worth talking a little bit about Raspberry here? Because I kind of see that as sort of like an early experiment with a different sort of like a continuous version of this that you didn't decide to make into a full game, but it kind of feels a little similar.
Yeah.
Could you give a little background on what Raspberry is as well?
That's what I was prompting. Sorry.
This is something you could actually download the old version of. There is I actually worked and never re-uploaded. I have a much more sophisticated version of this game, but you can download the one. I made Raspberry and a couple other prototypes while I was working on Braid. I was feeling burned out like 2 years into development, and I spent like 2 months just working on other side projects. If you search for my homepage, I still have some like hand-coded HTML thing that I don't really maintain. Like every 7 years, I'll go and like tweak
put
something.
Under construction on it. You're like, hey,
I never did. I never had the guy with the little pickaxe or whatever.
Marquee tab.
But there's a game prototype on there called Raspberry. It only runs on Windows. Sorry. And so the idea behind this was a little bit different, but it was about combining game mechanics. And I didn't think about it this way, but it was like, okay, what if you made a game where you tried to use game mechanics like music, where you'll have one interaction that's like you're trying to click on things or something, right? And you have another interaction that's like you're trying to dodge things. And what you could imagine some number of very simple things like that. And then like in a song, you might have like drums come up really loud for a little bit and do stuff. And then you'll have, you know, guitar come in or whatever. And sometimes you have everything and sometimes you have one thing. It was about just composing these gameplay interactions in that way over time. And it was a good experiment. What the conclusion that I came to was you can't exactly do that in the same way that music works, because game design is like fundamentally a little bit lower frequency in the sense that the rate at which your brain can track the changes in what you need to do has some maximum rate before it just is not that fun. But it did work in the sense that like, oh, this is kind of cool and interesting. And maybe I should ship, I mean, I would have to dig it out of source control and compile it again, which, oh my God, compiling a C++ program from 15 years ago is difficult. But
but here, C++, it's still way better than the front-end world for compiling bad stuff. And if it was on MSVC and only on MSVC, the visual compiler, if Microsoft is doing like one thing correct, like it's astonishing how backwards compatible these guys are, like with their tooling. It can be C++, MSVC like 195 now, and it can still compile old C++. Like this way is just awesome. So
you know, yeah, that was related. So I think it goes to show that I've been thinking about this kind of thing generally for a long time.
Would compiling a Jai program or a J program or the language program in 15 years, will that be a challenge or will that be smooth?
Well, it depends. So part of the reason we're keeping it in closed beta right now is to give ourselves the permission to change things in a somewhat incompatible way. But because there are like 1,000 people in the beta now, we still try to smooth it out. So like what I'll do is I'll say, okay, this feature's going to get deprecated and replaced by this other feature. So first we implement them both alongside each other, right? Then a month later, this one gives you a warning when you use it, right? And then a month later, it gets deleted. But if you take a year off and come back, you might have missed that, and now your program just doesn't compile, right? And there's information in the changelog about why, and sometimes we can even leave error messages that say, oh, this isn't how it works anymore. But yeah, so now there's different levels of changes that are different levels of severity and stuff, right? But what I would say is, okay, so the reason we're doing that is because of my experience with languages like C++, where they had a lot of ideas early on about like what would be really cool ideas and make programming better. And a lot of those ideas are very inaccurate. There were other things that they really should have done early on, like that C didn't really do. And not to blame C, but like in the days of C, it didn't make sense to think in a very clear way about integer types, let's say, because there were just all sorts of computers with all sorts of different word sizes. You didn't know what was going on and like all these things. But like now it's like, it's pretty obvious that like, if you have an unsigned 8-bit number, that'll fit into a signed 16-bit number, right? If you just, and that should implicitly cast, but if you have an unsigned 16-bit number and you put it into a signed 16-bit number, you maybe should say that that's what you meant to do, right? And it eliminates, and like they weren't thinking about that kind of, I'm not even saying that that's exactly the right decision that you should make, but it's like a clear idea that should have come up, right? And they just weren't thinking about that stuff, and they had all these other things that they added to the language. And the problem with C++ now, or one of the many problems with C++, I would say there are two core ones that drove me to make a new programming language. One is that C++ is completely saddled with almost all of the baggage of almost
Jonathan Blow is leading this interview, no?
every idea that was ever introduced, and there's no way to deprecate things, right? So that's a problem. And so that makes the new features worse. So if you actually have a better feature that actually will help people, it actually doesn't work as well as it should, and it's harder to implement and slower because it has to interoperate with like all this cruft that's like built up over time, right? And so there's a lot of things they just can't really do. Like I haven't tried to use the modules feature. I sort of froze my C++ usage at C++11 and even only some of C++11. Like I do, you know, probably less severe than like Casey, you actually use C++. You just don't use most of the features, right? But
yeah, I kind of gave up on C++ features a while back.
Yeah. But like Sean Barrett didn't even use the C++ compiler forever, right? Like he was using the C compiler, which was not maintained anymore. But it was like Jeff. So much faster than the C++ compiler.
Same with Jeff Roberts. Still I believe to this day, when he has his own stuff, if he doesn't have to interoperate, it's the C compiler only.
And like you can't. So in that dialect of C, the last one that Microsoft made this compiler for, you can't even like declare a variable in the middle of a block. Right?
Like, what?
Only at the top.
It's bad. Like original C was really different from modern C.
Yeah, modern C has like added a bunch of those conveniences in now, so it doesn't feel that clunky.
By the way, by modern C, are we talking like 89? Are we talking 99, 11?
Well, I haven't followed anything since ANSI C, right? I know there's like C99 and stuff. I don't know what those features are.
In C89, you need to declare variables at the top of the procedure, like in Pascal. So this means that you cannot even specify in the for loop to say int I. You need to remember that you're going to use this index and you put it up there. So if you have 3 for loops and you don't want to share this index, you need to put them up there. C89 is the flavor of C where a lot of software that is being used today, like curl, is being written. And Eskil Steenberg is a huge proponent of using C89, but this is like hardcore. Even for Ryan Fleury and Ginger Bill, C89 is a bit old tech.
Okay.
Really, we just mean if you go download a C compiler today, whether it's Microsoft's or Clang or GNU C, they now all have things that you would have been very happy to have way back when, like including like how like a for loop might get scoped for variable declaration, how you would whether you could use declare anywhere, those sorts of things. They didn't have any of that, right? You had to put all of your variables at the very top of the function and all that sort of thing, right? That was still the norm in like the year 2000.
So K and RC, when I was in college, I was learning C, and there was this shiny new book that said ANSI C with a big stamp on the front. But in the used bookstore, they had a book that looked almost the same. It was the same like C programming language book without the ANSI C stamp. And I was like, that's pretty cheap. I'll learn from that book. And that was the K&R version of C. And so I was using compilers at school that could do the newer C stuff, but I didn't know that. And so in K&R C, for example, if you're going to call a function that's in another file because you're organizing your program, you don't declare the arguments of the function. Just whatever you pass to that function, the compiler says, sure, that seems fine, right? And so then you spend all this time debugging because like you passed a double instead of a float, or you forgot an argument or whatever, and you just crashed at runtime, right? There was no static type checking on external functions.
That feels like my experience with Elixir. I did this very regularly, tried to pass things in and getting the wrong types constantly.
Yeah, it's exactly what you need when you're just trying to learn, Yeah. It's
well, I mean, we say this, but like, welcome to JavaScript, right? Like fast forward to today, and like a very standard programming language is still in the state where it's like, yeah, I don't know, you just pass something, and
whatever you want, man.
Whatever you pass is what gets passed, and good luck.
Yeah.
Yeah.
I mean, to be fair, most modern JavaScript, they use, TypeScript, which alleviates a good portion of those problems. There's still the problem of outside objects coming in. You have to literally hand validate them with some sort of runtime checking to prove that they are what they are.
Are you sure most is true here, though?
It's like all like 75% of new projects. Okay. It's like some decently good number these days, but nonetheless,
that's nice. That's nice for the youth.
Of new projects. And a lot of people is working on the old code bases that are still out there. Not the brand new AI stuff, but the huge behemoths.
The youths.
That's nice that the web finally figured out about types.
My favorite part still is that we take a language that cannot be interpreted and turn it into a language that can be interpreted, and we call it compiling. It is like we're in a very weird world in that side of the universe, but it's very fun. All right, so I want to actually steer away from I love the C++s and. Well, actually, I don't actually genuinely hate it, but
yeah,
this is great discussion, all. But I actually want to focus on kind of a question with Jai and or Jay. By the way, do you call it the language Jay or Jai? Or
yeah, I don't pronounce
or John's
it. So,
artificial intelligence.
So I have an allergic reaction to one of the. So I'm very frustrated with the quality of software, broadly speaking, right? And part of that is the culture of what are people thinking when they sit down and make software, right? And there's a pattern that I notice that bothers me that doesn't seem to bother a lot of other people, but both in academia and industry. If you read an academic paper that's about somebody's algorithm, right? There's
this mic. This is the maximum. I have audio interface, but this mic is like requiring heavy power, and that's the maximum now. Volume-wise speaking.
There's a very classic form, which is they put the cool name of the algorithm that they made up, like the marketing name, : and then they tell you what it means. And Hacker News posts are the same, like Django poop, : a thing that converts all your comments in JavaScript to uppercase, right? and like they come up with like the seemingly, this is my cool project name for like something totally stupid. And it's like all the effort goes into thinking about the name, or like thinking that if you make a really neat name, then you've passed some hurdle of being a contributor or whatever. And meanwhile, I'm trying to implement this algorithm from a paper, for example, in a video game, and like realizing that it doesn't actually work, and then sometimes under very strict deadlines where I suffer greatly due to this, and just it really frustrated me. So this was just like a code name that I made for this language. I don't ever use it. We don't market the language. I don't have a logo for it, which is another thing that people make like first before, and even when it comes to language syntax, like if you start talking about what languages should a feature have, people will talk about the syntax because it is the most concrete and easy to observe thing, but it also kind of doesn't matter that much. I mean, it does matter at some point, like in the end, once you finally have a tool that you're like, this is the thing I'm going to use day to day for years, then small amounts of friction do add up and they really matter, right? But the problem is that if those are the main things you're concerned about when you're designing a new language, those are relatively shallow problems that you're preoccupying yourself with. And
the thing with that, like, Jai, just an idea, I asked Jonathan last time about whether this was like an abbreviation, and I meant this in this hopeful way, like just an idea, like we can really do things that are smart and they're like aiming high and are important. And he ridiculed this idea dramatically, like he terrorized this, and he was like, just an idea, you do stuff. It was rough.
And what I found, okay, so let me get back to this other thing that you sort of asked at the beginning, which was,
but this is interesting. Jonathan is not saying Jai. And I think there's an urban legend that he never said it. He never pronounced. So it's like it technically has a name and extension and like for files and everything, but he never pronounced it for the decade.
It was like, why did I make the language? Part of it was I was sitting there using C++ every day. So Casey visited in these days and worked on The Witness, and we had both an annoying like asset processing pipeline for the game, which I won't explain that right now, but it's like, crunching the data that's going to go in the game sometimes would take too long, and that slows down your work process. But also just compiling the game was really annoying. It would take like a couple minutes, which doesn't sound that long, but it like really breaks your flow when you're trying to think about stuff. And it was only a couple minutes because we spent a lot of.
Oh, he said it. Okay. Then the urban legend was actually legend. So it's officially Jai.
Effort trying to minimize the C++ suffering about how long things take. And so I was like, I have all these problems. Like I was kind of sad and depressed working on this game, even though it was the best thing I had ever made. And it was clear that it was going to succeed at some level. I mean, who knows about commercially, but like artistically, we had at that point succeeded in making a good game. We just had to finish it, right? And I was still bummed out going into the office every day, just working on this thing. And I was like, okay, part of this is the programming language, and part of it is the asset stuff. And the asset stuff we can look at next time we make an engine. The processing, the programming language, though, I would go online and look at what are the conversations people are having, because like there's a C++ committee, right? And then there's other people making other languages, and like why? What are they saying is their motivation? And I would look at the problems that they say that they are solving, and they had very little to do with the problems that I had from day to day that was making it hard, right? And the thing is, like when you're working on a smaller program, or you're working on or you're a new programmer, right? You feel like there's certain things that are serious problems, but actually when you get more experience, you're like, yeah. Like you don't really make that many syntax errors when you type later. But if you're a new programmer, you're like, syntax errors are really, I'm drowning in syntax
like
errors.
baffling.
This is obvious.
Who
Who
could
could
have
have
You're
thought
like,
of
what? Why?
semicolon?
What? Yeah.
Yeah. Now it is true that better syntax error messages can help people learn really fast, but that's not like a deep. So what I found was that once, and I think this is obvious once you say it, but like once programs get past a certain size of code, and or because it's like some kind of product function, and or a certain complexity of like the internal data and how it has to be arranged, and like, you know, what the structures look like and what the constraints are. Once it gets past a certain point in complexity, it's just hard to work on the code because it's hard to understand everything and see everything and just know what's going on. And that's kind of the bottleneck, is that it just gets complicated. And so that's what I wanted help with, was like code that just gets really complicated. And I was looking at what people were talking about, and they just didn't have any of that as a concern. And then the other thing was compile times.
Can I inject one thing there too?
Yeah.
When you look at like the biggest thing that frustrates me when I've looked at things like C++ committee discussions, or how they go about like deciding what and how to put in the language, is the mindset, in my opinion, when you're designing a language, has to be that we are trying to make the best possible system for the working programmer. Like the person who's going to sit down and is trying to get their job done that day. That is what you need to, unless you are making, like if you're making some abstract, like, you know, like ML or something like this, or Lisp, and you're intentionally going down that road to make a theoretical language, then that you do whatever you're trying to explore. That's your thing, and that's fine. But if you're like the C++ committee, your job should be to focus on what is going to allow the working programmer to have the tools they need to succeed every day, right? But if you actually look at the way that they make decisions, it's almost all about weird, esoteric, theoretical things. Like they will never go like, okay, well, we have to make this thing work because this is what would actually be effective in day-to-day work. So we'll go and we'll deal with ugliness in the theoretical realm or something as a result. They will never make those decisions. And it always ends up feeling a lot like, you know, you're in some like rundown, like dilapidated shack. and someone's like, okay, we've got this beautiful mansion that we're going to move to. And they're like, whoa. We can't move to that mansion. I planted this tulip bulb back at the shack, and I don't know how we're going to move that. Right. And like, literally, like you're reading like, well, I'm like, what? Like you guys decided you can't do any of these things in the good way that you would have done them because of this one little thing. And no, like this is why the language keeps getting worse. And so I do think like there's in some languages, they've calcified this very academic process for like moving the language forward, and it always results in substandard features over and over and over again. So anyway,
and can I also?
There is an old interview on this podcast when it was called Game Engineering Podcast, when I talked to Guy Davidson, who worked for more than 25 years in creative assembly on Total War games, and he's an ESO C++ member. And he walks me through the process of how the committee works and operates. And first of all, you can tell by the process, a lot of the C++ things, they happen in a like, you can tell why design by committee looks like a weird semi-democratic kind of thing where there's no cohesion for features often. But second big part is that like language designers want to design languages. So people who are motivated to pretty much for no financial recognition, because they don't really get anything from it financially, who will spend their time to be on the committee and like go through these proposals and write like never ending, finding all the edge cases, people who really love it and want to add something. It's very difficult to remove something from the language because it's then breaking compatibility, and there's no process for like reducing it, you know? When you have like databases that are accepting tons of traffic in the log fashion, like you can stream data to Cassandra, Apache Cassandra, and it will accept a ton of data, and at some point there will be a compacting process which will take the data that is there and compact it, compress it, and put it out. And if there was a tombstone, which meant like delete this data, it will be deleted. So there is this process of like first the data lands sort of in a weird fashion but fresh, new, and there's a compacting process that happens in the background, and it will get rid of this data. And there's nothing like that for C++, the language that is now like 40 years old, and C adds a lot of like additional 10 years or so before C++. So it's all of this baggage still is in the language. And you can tell that there's a code written in like 2010, and there's other pieces of code that was written like before 2000s, because like one looks like C, but it's actually C++. One looks like C, but classes and uses all 4 types of inheritance, and like this is crazy things. And now the modern C++ will use functions everywhere and put like lambdas and std function and put them like, you can just mark like carbon. There's this process of like finding out how things are old through the carbon footprint, how much the carbon have. You can just tell by looking at code base when it was written and what was the hype in C++ world.
Say it does feel a little bit different too if it felt like, I mean, we already made the joke about it being impossible to build an old C++ project. It'd be one thing if I could pull any C++ project out from any time and they're like, you have a random one from 1997, you can compile. Yeah, but I feel like so it's not even like you're getting this feeling of like, oh, I have this rock solid thing I can always build. It's like, we're going to keep all the features around, but you still can't build it. Like, what is
you get nothing.
This I don't get. I feel like they might be like, so if you select an older version of C++ and you will compile it as an older version, it will work. And a newer compiler will know how to compile the older version, no? So what's this I don't get.
From it, yeah.
So anyway, that's like the history of all of computers, really, is like there's these stated reasons why things are the way they are. We need to do it this way to get this benefit, and then you actually ask if you get the benefit, and it's like, well, we get 5%.
Yeah, like no, not really.
So the question would be, is that a design by committee problem? Because John, you're effectively the decider of the language. You're the benevolent dictator of it. And so do you avoid a lot of those problems because you look at the tulip and go, this part of no one. Like you can just make that decision. You don't have 5 people of the 10 being like, that tulip is life. I cannot let go of the tulip. Like you don't have to make those fights. You can just say, no, this is the way. It's the best way.
Yeah, what I would say that the problem still occurs even if you have a benevolent dictator, because you do want to listen to your audience a little bit, at least as part of a grounding. Like, so even if you think you have the best ideas and nobody else can have better ideas, which is not usually exactly true, you still need to listen to people to know, like, okay, I have an idea that doing this feature this way will help a certain class of program. There's people out there writing that class of program. They can tell you if that feature actually did what you meant it to do or not. You can't quite do all of those yourself because you're, like I said, the real problems happen when you're like deep in a very complex program, and you can write like little demo programs to test your features out and stuff, but you just don't have enough human life years to like write all these super deep programs. So you need to talk to the people who are using your thing, and they're going to have all different opinions about what you should do, and you need to just like not listen to some of them. Like that's simply how it is, because if you listen to everybody with an equal weighting, it is equivalent to design by committee. And so you just have to say, I'm sorry, it's, you know, for some people, it's not that you necessarily have a worse idea or anything like that, but this language has to pick a direction to go, and it's just not that direction. And maybe a different language could go that direction, right? And maybe that's better. Like we're just, you know, you're doing some hill climbing process, right? Where hill climbing is this thing in computer science where you start out on some landscape and you only can look nearby probably, and you just go the way that seems the best, but you don't exactly know. And this is an entire class of algorithm in computers, right? And so you're kind of doing that. But you have to, if you listen to everybody, you'll add up all these vectors that point in all these different directions, and they will sum to 0. And you will not go anywhere, right? And so that's like, so you just need to be willing to be a little bit, like, not even exactly disagreeable, because you don't have to argue with people or anything, but it's just like, look, that's just, I appreciate that you want this thing. It's just not what we're doing here.
You have to have conviction.
Yeah,
right.
Something like that.
Yeah.
You have to not be
ideology, right? Like, here is what we're trying to accomplish that includes some things that you will take seriously and some things that you will just decide we're not going to do. Like, right? If you tried to do, I mean, C++ also has a little bit of that problem where they don't have a strong idea of exactly what we are trying to accomplish at the end of the day.
Everything.
So, right?
Everything
and nothing, sort, right? Like they all, it's everything and nothing somehow, right? And so, you know, it also pays to have, separate from design by committee or not, if you're going to have a committee design things, it helps to have an overriding idea of like, we are trying to get the language to this place and accomplish this thing, so that we have like a guiding principle. Like I said, like make the working programmer's life easier every day or something. Like there's something like that you could point to, so that somebody on the committee can argue, look, we're just going to have to trash the tulip because we really need, like, this mansion is going to be so much more helpful for everybody, and we need it to be good or whatever. Anyway, I interrupted John when he was about to talk about compile time, so maybe we can jump.
Oh yeah, well so there are friction things, and so when people talk about like, oh, the syntax needs to be good or whatever, they're talking about the minute-to-minute pleasure of using a language, and for some reason people focus on that. And then, it takes 2 minutes to compile hello world now. And it's like, what happened? How am I supposed to have a thought process? How am I supposed to develop when it's like so painful that I just sit there and wait to see what happens? And so that was an emphasis from the beginning. Also, because I come from the world of video games, like even a video game 10 years ago did an insane amount of computation in one frame. Especially on the GPU, which is a highly specialized, very parallel thing. But even if you factor that out, the amount of stuff that a video game does just to figure out what to put on a screen is very high, at a very high rate. And it's because that was just like the fitness function under which the industry evolved. People wanted games that rendered smoothly and looked good, right? And like for some reason, no such fitness function exists in programming languages. There is one, but it's like, it's something about how cool of an anecdote can you post on Hacker News or something, right? It's like it's not really to do with usability. I mean, at some level there is, I don't know, it's complicated, but so looking at these compilers, I was just like, look, I've written compilers before, never as serious as this one, but like in college, I wrote like 12. Instead of doing my homework and doing classwork, I wrote like 12 compilers for different languages. And so I knew how it worked and I knew what they were doing under the hood. And I was like, it's way less computation than a game does actually. And so it should be really fast. And so, part of the goal was to just try and fix that. And because, we've done a pretty good job at that. So our 300,000 line game does a full build. We don't have incremental builds because that's, in my experience, another source of bugs and confusion. Like even the more you have to think from minute to minute about what are all the different ways that a thing might be building and which one is selected, right? It's just another roadblock. And so it's just like, look, it's a full build all the time. Right now, that takes about 2 seconds for a debug build, which is longer than I wish it was. I wish, I feel like it should be like a quarter of a second. But we've reached the point where with the team size that we have, it's hard to push that number down without concerted effort. And we're still trying to ship the game and all that. But that's still, a lot of these other languages that have been made in the past 10 years, how long does it take them to compile a 300,000 line program? Like way, way, way longer. And it's just like decisions that are made about how the language works.
Yeah, 2 seconds is a lot less of a temptation to pull out my phone and forget everything that I was doing than 2 minutes or 20 minutes.
Yeah, right? It's like just short enough, because if you turn around to do anything, the prompt will come back up. Right?
Yep.
Jonathan Blow mentioned recently on the LambdaConf talk, he compiled live his 300,000 lines of code project, which was the Order of the Sinking Star, the game, in 2 seconds. To compare this, my project at work is 200,000 lines of C++. And if it's compiled from scratch, after I've done a ton of work to do the header reorganization and to make sure it's working real fast as possible, it's, depending on how you compile it, still something like 10 to 20 minutes. So, well.
Actually, personally, I think it's really impressive. 300,000 lines for 2 seconds. In modern development, that is genuinely unheard of. Because, even in my personal, interpreted languages, as of recent, it often takes more than 2 seconds for significantly less lines. So this, that is actually, in modern sense, a very impressive feat.
Yeah, so that's something that our beta users enjoy, significantly, is that sped up iteration.
I know we've got a hard stop. I got a few last quick questions for you, if that's all right. So
sure.
They might not be quick, so then you don't have to answer them too. So we'll just
one-word answers.
All right, okay.
I got some too.
All right, here you go. Do you think that AI is going to save the games industry by forcing RAM and GPU prices up so high that people actually have to care about performance?
Interesting take, Teach.
I'm not sure. Okay, we'll not try to one-word answer that.
You can also include web development as well.
Yeah.
Okay. Well, yeah, I don't do web development much ever.
Yeah.
But so this is a problem. Like games for a while was known as the place where there were still a lot of really good programmers, because we were like forged in this fire of really difficult stuff, and that's become increasingly untrue. I think game programmers are like reverting to the mean, and so it wouldn't be too bad. I don't think that, I think things are going to adjust and RAM prices are going to come back down pretty soon. This is just a short frequency trend, like all of these.
Yeah.
But yeah.
Prime, you want to ask one?
Yeah.
We can alternate.
Yeah. Common Wisdom says, or at least Common Wisdom on Twitter, so it may not be actually Wisdom or Common. It suggests that you should be making a game and getting it out fairly fast, and making sure your concepts are good and getting it in front of people and all this kind of stuff. You shouldn't go and hide yourself away for many years to build one game. You obviously having the time to build a language, build an engine, then build a game, 10 years total. When do you make that decision to say, actually taking your time, taking the 10 years, taking the 5 years, this is actually the more superior choice? Like, when do you know to make that decision?
For me, it usually happens gradually. So all of these projects I would have envisioned being shorter. Like this game was supposed to be.
I will clarify things in chat. So if you're interested to get into the beta, there is an email address that you need to find and send an email describing why you should get it. And at least judging by the amount of things that I've put in my email, it is not that hard if you can make a case for it. And it's just a matter of finding the email address, which, like, if Jonathan Blow is not putting it publicly, then I won't disclose it, but let's just say that like if you're interested in the language, there's content outside by the author that you can find about the language back in the day, and the email is there. And Jai is not LLVM based. I mean, it has x86 backend and LLVM. So it's not only. How can I access the member-only stuff without paying YouTube? I want to pay only you. You can be a Patreon member as well. It's a lower cut Patreon takes than YouTube, but it is a great help by these platforms, even though I'm not the biggest fan of the owner of YouTube anyway. But it is a great difficulty to set up all the financial infrastructure and make sure that you're there for all the legal disputes about refunds and stuff. So the cut people take for processing financial transactions is like sensible. If you want to donate money, there is ability to donate directly on my website wuka.sh. This would be lowest pay cut, but you shouldn't be like worried about the cut. Like, don't worry about it. If you're willing to support this, like Sam just now became a member on YouTube. If you're willing to support it, then do it. I will be very happy.
The proof of concept game with like a simple engine just to prove out the programming language, and it turned it. I just always want to do a good version of everything, and then I don't know. There was like a lot of weird stuff that happened over development that I won't go into about like what different people on the team want and things. And so we ended up making an engine that's actually more sophisticated than the one for the last game when I was hoping for simple. But it means the game looks really beautiful. And yeah, but here's the thing. So I think that advice that you said is the right advice for someone new to games or just projects generally. Like if you have never shipped anything before, you should not spend 5 years in a back room doing something. Because you're going to be miscalibrated. You're going to be slow at what you're.
By the way, shout out to Nuno, who was one of the, I think, 4 first members of Jai Beta, and who created ArcVCS that you can look for at arc-vcs.com, which is a Jai, written in Jai VCS from scratch that aims to address perforce and Git LFS problems, especially for video games, but pretty much any large-scale project that has binary files. So based Nuno, who is having a nick here, Nafonsopit, and responding to all Jai-based questions. He's and Valigo as well, who is also streaming a ton of Jai development. So these are core Jai people.
You're not going to have the right amount of experience. And so being quick early is a good way to just iterate and learn, right? However, somebody's got to be working on really whatever you want to call it, like moving things forward and not just trying to release something and make some money. Like there have to be adults in the room somewhere who are worried about actually improving life in some way. And sometimes that's just really hard. If you could find a way to do that, in fact, there almost always is a way to do that that's actually small and incremental. It's just, that's not the way that I think, apparently. But for me, it's a lot more about motivation. Like if you can, yeah, however long it takes to do something that's genuinely meaningful is how long you should take, if that's your lot in life. And that's different from the guy who's like, I'm supporting my family by having a job. That's cool too. That's totally fine. But we need some percentage of people who actually are trying to like lift up the quality of things. Otherwise, it'll just be an eternal slide into a pit that we never get out of.
Recently, also, oddly enough, there's been some examples of these kind of long gestating games that I think might have also been first times. Like I want to say both
Blueprints was like
Blueprints and Animal Well. I don't know if Animal Well was his first though. We're both very long gestating single person or close to it games.
Yeah, and so if you think you can hit the target,
you know, and they sold fantastic. They were very, very popular, right? So it's kind of hard to guess what's going to happen. I think you just It's nasty.
Yeah.
It's a
I
nasty
mean, the thing that
business.
we don't see is how many of those did the
Yep.
same strategy, and they just didn't have the
Yep.
best idea or whatever. I don't know.
Any advice for people balancing CEO of game studio and someone who wants to be programmer/designer?
So the way that I do that is by not CEOing very much, because as you know, programming takes a lot of time, and game design also takes a lot of time. So one thing that I'm doing this time that helps somewhat is I did sign this game with a publisher. This is the first time that we ever did that. Part of that was to get additional funding to help finish the game, but part of it was just like they have a whole infrastructure for like doing stuff that left to my own devices I would do, but not as well. So like marketing the game, like they're running ads for the game right now. I wouldn't be running ads for the game right now, and like all these things, just like. So we're kind of delegating some of that to this other company who now also has a financial interest in the game succeeding and all that. And so I think that's good. I don't like want to run a business. That's never been my motivation, but I have to in order to be able to do what I want to do. Cause like nobody's going to pay you to do some weird thing that they don't understand. Now in the earlier days, the game business was easier. And so I could kind of be a little bit more just lackadaisical, especially like when there's no teams. It's just me working on Raid and like with occasional contractors. It's a lot cheaper, and it's like you can just make whatever decision you want. And it doesn't matter that much. Now there's like a pretty serious burn rate, and there's people, and like so I have to balance this. Like we have to stay in business and not be like constantly losing money year after year. But at the same time, if you turn into generic business making generic product, that's also bad because it's not what I signed up to do, and people are not motivated by that because there's just a bunch of the same slop out there, right? And so it's actually kind of hard. And in the past couple of years, we have survived the massive slaughter of 2023 to 2024 that affected a great amount of game industry. So we'll see.
Okay, I got maybe one, maybe two more. We'll see. I don't
mean, we started late, so you know.
Yeah.
Okay, I just want to make sure first off, do a quick time check because we had questions I don't want to exceed it. John, are you good on time? Do you have to end at the same
I
moment?
should be okay. I've got up to maybe 10 minutes from now.
Okay, cool.
Okay.
And whenever the gas runs out in the Starlight.
So the reason why I do have an out is because immediately after this,
I think
there
he's
will
in the
be
chat too.
a live interview on the WooCash podcast, which you can see on YouTube at least. I don't know if he's on Twitch.
If he's
but
on
he's
Twitch,
on
let me
YouTube
know
for
because I'll just raid right into it.
yeah, that's going to be, it's going to start at 11 a.m. my time. I don't know what that's everybody else's time. So yeah.
What? Unbelievable.
Cool. All right. So I don't know if you've answered this one anywhere. I could not find it. You don't have to give us an answer if it's still if it's a secret. But why did you call it Braid?
Some of these things are just creative decisions that happen at a relatively deep level that I don't like to explain them.
That's fine.
Because sometimes the magic is in the non-explained things. And so I'll just say there's some kind of, the idea for the game involves like a mood and a feeling and like a texture. And that was just part of it. And that's all.
Cool.
That's fine.
Yeah.
I got one that I feel like is really good for Twitter.
Okay.
If you could give a 1-minute piece of advice to all people coming into modern web dev.
I don't know anything about modern web dev. What? Don't do it. What do you mean?
Well, because that's where a lot of people enter into, right? Like that's just
Sure.
that will always be the entrance, and because it's just the easiest to get something on the screen and theoretically make $1 million by making another chat wrapper. So
yeah.
So if you were to give somebody an advice other than don't do it, what would you say to them that could potentially put them on the right track? So in 10 years they look back and say that guy was right.
I'm gonna say what I think the right answer is.
Okay.
And
you can't say
this
don't
may
do
not-
it. You can say whatever you like, but
yeah, still don't do it. But here's the thing. Okay,
Why is
the web
internet-
started. I saw the web started. I saw the very beginnings of the web and chose not to participate. So just to spend like 30 seconds giving a little background, I was at UC Berkeley. I was in this place called the Experimental Computing Facility, which is just like students enthusiastic about programming. The GIMP guys were there a couple years after me. That's why the file extension for GIMP is .xcf, because they came out of like the same computing lab. A little bit of trivia for you.
I did not know that.
I've always
Yes,
wondered
that's
about
good.
that.
So the X in XCF stands for experimental.
Yes. So this was like when, if you had a computer at home, it was like a Commodore 64 or like a not that good of a PC. You didn't have an equivalent of a Unix operating system at home. That was not a thing. And so if you wanted to program real programs on real computers, there were these workstation class computers that were in relatively short supply. There was a whole controversy that like the XCF snagged allocations from the university that were meant for another group called the Open Computing Facility. And there was like a war between the students about this. All that happened a little bit before I showed up. Okay. So there was a guy next to me named Pei Wei, who wrote one of the first web browsers before I even knew what that was. It was called the Viola browser. It doesn't exist anymore, but you could look it up. And I was at an early conference and Mark Andreessen was there and everybody was angry at Mark Andreessen.
Something's never
so-
changed.
He was making the Mosaic browser at University of Illinois Urbana-Champaign, and web browsers didn't have images
Looks
at that
like
time. They just
they
couldn't display
finished.
bitmaps on the screen. And there was a discussion underway that was one of these laborious committee discussions that Casey's talking about, because it was like, we're the web community. We want to make sure we think about these and do everything. And he was like, angle bracket IMG angle bracket file name or whatever, URL, boom, it puts it on the screen. And they were all mad at him for implementing that and having images in his browser before everybody else. So that was my experience of the web. And like, I didn't really love it. I didn't stay in web from that time. But it was so even Viola, right, was very visionary in the following way. It was not just a web browser that put the text on the screen, but it had an embedded programming language that was interpreted. It was a lot like JavaScript, but it was a different language. So it was not really semantically equivalent. And then JavaScript came again, a couple years later or whatever, 96 or whatever year it was, 95.
Yep, December 4th.
When Brendan Eich famously did it in 10 days, right?
Mm-hmm.
The reason it made sense to do something like this in 10 days was that, like, look, it's just to change a couple state variables in the browser about whether they push the button or it's not for real programs. So it doesn't need to be very serious. And so we don't need to use all this. And we want it to be cross-platform. So it's just going to be a very lightweight language, right? Okay. Fast forward. And now it's like the language that most software is written in, right?
Yes. What
nobody thought that
JavaScript will be written in JavaScript is the considered truth of JavaScript.
Yes. And so the problem with all that is that somehow we forgot all this thing that we knew about programming. Like it kind of like it doesn't matter what programming language you use because the computer knows how to run some backend representation, which in the old days was machine language, right? So then you move to the browser, you're like, we want it to be portable, so it can't be machine language, right? But like it wouldn't have even taken that long. If I had a time machine, it's like, do you try to find baby Hitler and re-educate him to be a kind and loving young boy? Or do you try to find Brendan Eich and say, look, spend 2 more days to make a little bytecode engine so that you're language agnostic on the front end, right?
Really big decision there at the time.
One of software's biggest questions.
Yeah. So I don't know. I'm not serious. Obviously, the answer is baby Hitler. I'm not. That's not really a joke. But because baby Hitler was so much earlier in time that maybe everything would have gone better after that. And what? Yeah. So, but the point being, like it used to be before the web that like if you wanted a language with strong type checking, you had your pick of a whole bunch and they all worked the same and they all targeted the same backend at the same level of quality. So it's not like you were using some janky transpiler to like build some massive 10x too large amount of bloat code that you can't debug or anything. It's just like they would target. I mean, those things did exist too, but you didn't have to use them because you had choices, right? And like we threw all that away and we made this thing where like now there's an interpreter engine and it just runs this one thing and then you can have wrappers around that one thing, right? Okay, so now we also ostensibly have WebAssembly, but it just because it came in later and people are not like all these companies also benefit from the fact that they're the only few people who can make browsers, right? As well, that there's no competition there. And so like Google loves that, dude. That's why they put so many resources into the browser. And so they're disincentivized from making it easy to retarget, like to control your own computing environment, let's say, right? Because if there's a very simple substrate and you don't need Google's permission to have new features or whatever, they can't leverage that against you in the future as part of their more like it would enable incumbent browsers to come in and displace their market share and all that, right?
It's actually worse than that because also you have companies like Apple who are actively invested in not having the web be very good because if it was, then you don't have to use the App Store.
Oh wow!
Yes.
Yeah.
No, there's
and that's not hypothetical. They literally you can literally go watch them do that in the minutes of W3C meetings, which I have done, and it's
we are still finishing up on the stand-up.
Every big company has a different angle on this,
yourself
but they're all kind of in common. Every angle is about kind of capturing more market share and preventing their current market share from being eroded in the future by competition, right? So this is all a long-winded way of saying, okay, there's good things about a browser. You can just open a web page and just there's a program running, and that's something that we didn't used to have. It didn't used to be that easy. But like we didn't have to throw away all the good things about system software to get that. And there's this fundamental confusion about this. Like if you just targeted an equivalent to a machine language, but that's cross-platform, well-defined, it has some instruction set, and then the browser was interpreting that, which is again ostensibly what WebAssembly is, but it like doesn't quite get there for I don't know, various reasons. And it's certainly not the default, right? But if we had that, you could run real debuggers on your web program, right? You could do all these things. And so getting that back, like those tools are actually incredibly valuable if you want your software to be high quality because they bring in a level of analyzability and understandability that we just didn't have once we made the jump to interpreted languages by default. So
by the way, on the understandability, have you seen LambdaConf talk from Jonathan Blow where he showcases codecs and what he can tell, for example, about memory leaks in Jai just by intercepting the compiler messages? This is crazy.
Getting back there would be great. And so this has been a 28-minute long answer by which I'm saying you could like work on getting back some of the things that we lost and getting them back into web infrastructure so that we could have the best of both worlds. You could have the convenience, right? But also the quality and robustness of older systems. And that would be great.
All right. I think you're probably out of time. I don't want to keep it. I definitely want Wukash to get pushed back. So
yeah, sorry. Long answer. There was not a one-word answer.
Okay. We gotta let Jonathan brew his tea because he's not a coffee enjoyer, but definitely he's tea enjoyer. And I need to make sure that he gets the link, the proper link to join here. And if that happens, we start. Your audio is quiet. This is the best that it can be, I think. I'm afraid. This is highest, this is highest. I will be very loud. That's my solution to it. Polska volume, exactly. I don't know. Probably Polska volume should be higher. I am afraid of saying just an idea now for Joy as a name of programming language. I am using exactly the same software that the stand-up is using, which is Riverside for the interviews. But Prime is way more advanced with the setup, and he can do like OBS and then plug this in as a thing and then overlay chat, and then everything is great. It's like, no, for me, it's like either OBS or basically that's it. Either OBS or Riverside. But yes, if you want to be like a hardcore Jonathan Blow fan, you cannot say Jai. You need to say the language. This is the official. And then you can say even trademark at the end. You say the language, trademark. Yeah, we have tons of questions to Jonathan, by the way. So, but we will attempt to do live Q&A, and there's lots of people now listening. I hope that you will not break my vibe coded Q&A app. So like be very gentle on the amount of edits on the Q&A, but you can submit questions here. Wait, no trademark, Dandy? So you say the language with capital letters, but no trademark? Then I'm off the loop. It's not just an idea. Don't tell this to John. Just AI. That's the name. Just AI language. Yeah, I'm not worried about people finding out my GitHub account. That's fine. It's all good. There's even like people go crazy because they see that there's a key to Firebase and this is the public one. So it's fine. And I don't store your passwords. There's just ability to log in through a third-party provider. So I'm like, the worst case scenario, we lose those questions. So this, when the language will be available, this will be one of my questions. But let's just say the answer is elusive. But there were plans in the beginning to release the Jai language when with the game to sort of showcase the ability that this language is powerful. I mean, not the source code of the game, but like when the game is being shipped, the language is being released as well. So we'll see. Public key farming is what people over at ssh.terminal.shop do. Okay, you can open up your terminal, especially if you're on Linux and Mac. If you're on Windows, you can maybe have a putty, but you can go to ssh space terminal.shop and you can order coffee, and you can do it even in EU. Hello.
Hello.
How are you
I'm
doing?
gonna make some tea for a few minutes, but I wanted to
Do you need
make
a
sure.
break?
Yeah.
We are live, by the way, because
Oh,
this is kicked off. So
hello
if you
everybody.
wanna share something, you need cannot share trade secrets of your game.
Well, I mean, what I should do is there should be somebody standing over here, and I should like cover the microphone and say, don't tell the press that this thing is
Yeah,
happening, and then somebody can read lips, and then
exactly,
I get busted. Yeah.
exactly. Do you want to brew the tea and have a bit of a break?
Uh, yeah. I mean, we've got like 4 minutes, so I'll do that. It's
Yeah,
the water is almost done boiling, and so I'll be back in a moment.
perfect. See, everybody was scared that it's gonna be delay, and Jonathan here is like 5 minutes earlier. Wait, nothing is shipped into EU yet? I can do the layup like this and it should remain steady. I'm not changing cameras. If it's too bad, I need to look it up how it looks like on the receiving end. Is something gone bad? Okay, now it's steady, no? It's steady now. Okay. Riverside had a internal issue. If Q&A site stopped working, it means there were too many edits. Which was like, I think, couple of thousand edits. So it should be working. Maybe edits like reads and refreshes were also counted. That's not bad. That's not good. Uh-oh. We ran out of free quota. Then you need to keep your questions until the end. But we already have a couple of them. They were upvoted. So some of them might be asked anyway. Yes, so the questions seem to be also the questions that I have prepared. So, Jonathan, do you hear us? Does it bother you that a lot more people seem to be excited for the language than the game? Wow, you want to roast Jonathan live? This is crazy. What am I supposed to do with the question? You can frame it differently. Wow. I cannot ask it. Not this way. So this interview is now live. It will be available immediately afterwards for members of the podcast in the unedited version, and then it will take me forever, like probably like up to 2 months, to actually edit this and fit it in the release schedule, because there's quite packed technical content soon-ish that I cannot talk about right now, but it's so awesome, the interviews that come up. So you can go to Wukash podcast and see all the cool technical interviews that happen.
Okay. Maybe that's enough. We'll see.
Okay, we can do a break in the meantime as well. Like,
no, I'm good. I think I've got a chocolate bar that Casey sent me. I've got you saw the large amount of tea.
Yes.
I've got cookies. I've got granola.
Chocolate and cookies.
I've got honey to put in the tea.
Healthy.
I've actually got 2 kinds of honey to put in the tea. So when I program,
tons of sugar.
You know, what's in your, what are your tools around your desk? You know how people would show like, this is my work setup or whatever.
Yeah.
They have all their computer with LEDs. My work setup has a lot of sugar.
Okay.
But granola, I guess, is high in fiber and not that high in sugar. And so maybe that.
Yes, but I would suspect that's mostly sugar anyway. And also it's US,
carbs.
So it's like
carbs. I don't think carbs are bad. I think carbs fuel you. So it's all good.
Okay. Very well. So let's start then. Welcome. Yeah. Hello,
hey,
Jonathan.
hello
for the second appearance on this show. First appearance, 3-hour long interview.
We'll see how long this one goes.
You know that Sean Barrett exceeded the record that you set.
Okay. That's good for him.
5 hours. It's 5
Whoa.
hours.
Yeah. Did you have to break that into multiple parts on YouTube, or is it just one giant video?
It's one giant thing.
All right.
It's and it was like in real life, it was one giant meeting with I think one break, because at some point it was me who couldn't follow up what is happening in the assembly style tricks of the old days.
Great. Well, that sounds like it was good.
It was a lot of fun. So, can we first start a little bit on the story of development of the Order of the Sinking Star?
Sure.
It famously took a decade, or it's taking
not
decade.
Quite yet. By the time it comes out, it will have been 10 years, which is absurd. And it was supposed to be a short. So there was a game that I really wanted to do that some people have played, and it's really fun. And I was like, I kind of don't want to go into a big, complicated development after The Witness, because The Witness took 6.5 years and was very tiring. And so I was like, we'll just do this short game, and then I'll go back and do this other game that's going to be. And then the short game turned into a giant situation for 10 years.
But the long game was the musical game?
No, it is not something that I have spoken about publicly. It's kind of just a secret, but
it's like a super secret.
And it won't be a long game though. Actually, I did speak about this game tangentially. There was a conference called Practice, a game design conference in 2014, and I talked there about like a game that I would spread out over like 20 years, which seemed like a long time at that time. Just in installments, right? And this is that game. And so the plan for it is still to do it in smaller chunks, kind of like if you have a series of fantasy novels that eventually becomes really big, you know, like the Song of Ice and Fire stuff that maybe someday will get finished.
Someday.
Yeah. You know, you can build quite a big, sophisticated thing in pieces, right? And so that was the plan for that, and definitely has to be the plan for that now, because I'm never doing a 10-year game again. It's impossible.
But whether the plan was in the beginning to have these now 4 islands like as actual separate games that would be released independently, or was it?
No. It was always to put them together. It's just that, like, when you want to believe things, you'll find reasons to believe them. So it's like, oh, we're basing this on existing material from other designers, right? So those 4 games are they're revised versions of the games, but both graphically, you know, much more sophisticated, and also just design revised. But they're games that existed already. And so I was like, oh, that gives us, maybe that's like 20% of the design work done. And like, no, it's like, it rounds to 0, the amount that, because we built so much game on the back end of that, and revised those and expanded them and all that part didn't help. And then in the meantime, this is a game that's fundamentally about a combinatoric explosion, which programmers know generates very big numbers very fast. And like, for some reason, when I was thinking about the game, I just didn't take it that seriously. I was like, yeah, it's about combining these worlds together, and that'll generate emergent gameplay mechanics, and that'll be really cool. And like, yeah, maybe there's a little bit of like a scaling issue, but we'll just deal with it. We just won't let it get that big, right? But then I just let it get that big. So, yeah, it's a problem. Like, it's maybe not a problem. We'll see if it's a problem. Like, so the question sort of is, do people play it, right? I mean, maybe that doesn't even matter. I mean, I saw some clip. Well, let's not go too far off topic, but, there's more reasons to do things than just like, does it find a big audience, right? Do you find personal satisfaction from it? Did it allow you to grow in skill and in your refinement of your person and in your understanding of the world? And all those things are true. And so this was mostly probably worth doing, even if nobody plays it. But you would also like a lot of people to play. If you put 10 years into something, it's like, yeah, you want people to just, even so, for financial reasons, you want to keep doing what you're doing, but also just like, the reason you put so much effort into something like this is because you see what's interesting and beautiful about it, and you just want to, you want other people to be able to see that. And so, yes. And that's also kind of how it became a big, long project, is just, you see what you've got at any moment in time, and like, here's what we would like to do to make it better. And like, okay, we could do this good thing and make it really good. We could do this thing and make it like not that good, but take less time. And a lot of the time people choose the less time, and maybe I should choose the less time option more often, but I didn't really. But what that does, though, is it puts you in the realm. So the reason people make those decisions is to defray some cost, right? Like, maybe it's directly the cost of paying people to work on the game. Maybe it's just the cost of like, how much time in my life am I spending working on something? But so if you're willing to pay that cost, you can end up in territory where other people just didn't get to. And then you automatically have something that's different from what everybody else has. But because you're paying the cost, it is a little bit painful to get there, right? And so that's how it went.
Did it always had the same size of the team working on it, and like the same
It has varied.
Programmers and like artists, like how did it fluctuate?
It has varied. What I will say is, because I thought it was a shorter game, shorter development wise, then we sort of kept not even just, so Witness development was pretty long. After that was finished, sometimes it's just natural for people to move on to other projects, right? So one guy from our art team, Luis Antonio, went off to do his own game called 12 Minutes, which, was released and was a successful game. And so, there's some attrition that's just natural. But like, because I thought, we're trying to do this game in 2 or 3 years, I hired up to like fill that out and like keep a full-size team for that time, which I don't exactly remember how many people it was. So the Witness, we had 8 full-time people toward the end, and then a lot of contractors helping out temporarily. These days, the company is like 10 people full-time, and then again, quite a few contractors. And so it has grown, like, let's say slowly over the past 10 years. But if I were to do it over, I probably would have let the company be as small as it was and just like built out the game myself and the programming language and all this stuff to the greatest extent possible. Like I hired some people to help with that. Eventually we found people who were good, but I don't know. Sometimes things just don't work out the way that you wish they did, and all that stuff. So, yeah, but it's a very different. So when I started The Witness, it was like I had done Braid as a solo programmer with a little bit. Actually, Sean Barrett helped on Braid a little bit. I don't know if you talked about that in that interview.
No. He didn't
Yeah, toward the very end, I was like really burned out because 3.5 years seemed like a really long project. And I was like, we're shipping on Xbox Live in like 2 months. I wish there were some better visual effects. Hey, Sean, do you want to come do some shader effects? So he did some of the graphical stuff in the game, and that was really helpful. But yeah, so okay, I forget why I brought that up, but because it was basically me with, some people who helped out on the side, but were not like part of the company, right? And then, so when I went to do The Witness, it was a process of slowly building up the team over time. But the good thing about that is it's cheap in the beginning because the team is not big. But then after The Witness finished, it was like more expensive in the beginning, right? And it's maybe not as useful to have a big team in the beginning because, having more people helps if you know that you want to execute on a certain idea, right? And it's like, okay, we need this person to do this and this person to do that and all that. But if you're doing something original and you don't exactly know what it is yet, which is a problem you don't have. For example, if you're making a sequel to a thing that already exists or whatever, then you know what it is and you don't have as much of a period in the beginning of being unsure, right? But for a game like this, where like there's so many things about the game that only got figured out after years of thinking about them, right? Because the depth of things to figure out was like really, really deep. In terms of the number of dependencies. I think people are less efficient because it's like, well, the art team is hanging around and they're sort of doing art for the game, but they also kind of don't totally know what the game, like, are we going to have an overworld? What's it going to be like? Like, how big are the levels going to be? Like, what technical features are we going to have for making the levels look good? We don't know exactly. We're sort of making some, and it just means that you can't like deploy people in an efficient manner in the same way. Nowadays, now that the game is getting close to done, one of the problems we have is like, there's all these levels because the game's really big. So we have 5 environment artists right now, just like doing art for the levels. But that is a relatively efficient process now because we know what the game looks like. We figured out all the technical implementation. We figured out the visual style choices that you need to make levels look good. Which usually is a several phase thing, so for example, in The Witness, we spent this time and we're like, how do buildings look and how do walls look and how does the ground look and all this. And then we eventually got the technical features in, we experimented with them, we figured out the style. And then we started doing we thought we had it all done and we started doing trees and grass and we're like, those same techniques for solid surfaces just doesn't make sense on trees and grass. So like, what do we do? And then that was a second phase of experimentation, figuring that out. And that's true really for any game that's visually original. They will have gone through that kind of process.
First of all, is there an official abbreviation of the order of the sinking star? Because
I think it's
long.
OSS, like open source software.
No,
right?
really?
I don't know. We'll see. Maybe you
X...
let people on forums and stuff come up with whatever they want.
Okay.
I don't know. The abbreviation was not at the top of my mind when I came up with the name.
Can we still call it Sokoban, or is it now like out of fashion? We should probably use the proper name.
So here's the thing. So Sokoban is not a very searchable word, first of all, because there's a long history of games called Sokoban, including the original one. So for people who don't know, Sokoban is actually a genre of game, right? And it has come to mean you push objects around or something to solve puzzles, but like there's objects in like a grid-like space and walls and whatever. That's a Sokoban game. But of course, modern Sokoban games are more sophisticated than that. But it all goes back to a game from Japan in the 1980s. It was a home computer game. And Sokoban is a Japanese word that means warehouse keeper. And so this was the warehouse keeper game where you've got to put the crates in the warehouse. And like for a 1980s home computer game, it was really good, like really compelling. At least for the first 10 levels. Like once you get past level 10, it like does some really unfair stuff. Like there's walls that look like walls, but actually they're not walls, and you can walk through them, and the puzzle looks unsolvable, but it's really solvable. Like stuff that you would consider cheap now, right? But in the 80s, honestly, video games weren't that good. So that was great for back then. And, you know, it spread. So I remember playing Sokoban games when I was in college, just like on a little Unix workstation. Like you would be running, you know, Apollo Domain OS Unix, which was like, Apollo was a workstation company that was competing with like Sun and Silicon Graphics and all these people and DEC. And then everybody had in the late 80s had to have a Unix operating system because that became the thing, but they all made them themselves. And so Apollo was a company, they had their own operating system underneath called Domain OS, and they wrote like Unix as a Unix emulator on top of Domain OS. So it was kind of slow and unstable. But that was the first operating system that I used at college. And there was like a Sokoban game that you could download that was open. It was like someone had re-implemented in C this home computer game that was probably in BASIC or whatever, right, from the 80s. So that's where it all comes from. What I would say is that the original Sokoban game, you would consider it kind of grindy now, where it's just, hey, I'm in a new level, and I have to think really hard about some invisible maze of dependencies about how I would move all the things. There is a little bit of like tactile, like I could push stuff around, and that feels good, and I can experiment, but there's not that much experimentation because it's not that hard to like get yourself into a situation that's, you know, unrecoverable, you know? Like I push something down this hallway and I can't ever get it out now or something. And so, and in fact, that's the challenge of the game, is to avoid those unrecoverable situations. These days, you wouldn't consider that fun. So how do you make a Sokoban game and have it be fun? The answer is, well, that's part of your job as a game designer. And I think every designer has a different view on that. For me, I'm using it as like a template to look at the way that game mechanics work and the way that rules in games can combine to create complex situations and the way that could be enjoyable. And that's something we did somewhat in The Witness, which I guess we haven't said this on this podcast. That was the previous game. It came out in 2016, which was quite a long time. I guess you can infer that from what we've been saying, but that was quite a long time ago, but there were some parts of that design that were really interesting and new to me, which was the way in that game that we focused on like rules and how rules interact, right? And so in this game, I thought I would just take that and like pump it up to a new level of complexity and depth. And that's part of why it took 10 years. Yeah.
Did it, over this 10-year period, have like different versions? Like you said that like trees didn't add up in The Witness, so you you needed to adapt like the artistic direction. Like did it also like change design wise or like artistic fashion?
In every category it changed. So visual art evolved. I mean, the final art style that we're using in our best levels only got finalized like a year ago, you know, which is very short on the time frame of the. I mean, we built up to that. We had a lot of things that we figured out, but the final game has a lot of like atmospheric, like fog and depthy clouds and stuff. And we had earlier versions of that, but just the technical implementation of them that we had for whatever reason didn't lend itself to, you know, to being used in really good looking levels. And so we actually have, you know, in shaders, you have a general class of effects called atmospherics, which are generally like you'll have some vector through the space that you're rendering and you're stepping along it to like sample points in that space and decide if there's some wispy cloud, like how dense is it at this point, and then you'll add up, right? And those are expensive because it's not like you're just putting a color at that pixel, you're doing a whole lot of computation for that one pixel, right? And then those tend to use data structures that come from other, so like if I'm sampling the density of this thing, I have to have some density function. If it's a closed form function, like you just made something up, then artists don't necessarily have control over that, and it can't react to anything, right? It can't respond to gameplay events or anything like that. So you tend to discretize that function and just store it in memory. So you might have some array, some 3D array where there's maybe 1 byte per little cube of space of like, what is the value of this function at this position, right? And then, of course, if you want that to cover a lot of space, or then if you don't have very steep changes in the function, you won't see quantization artifacts, right? Because you're interpolating over. Although, due to this phenomenon called Mach banding, you do see quantization artifacts a lot earlier than you would think. But there's ways around that. But that also, like a 3D array takes a lot of memory, you can imagine. And so there's kind of a limit to how high can you crank up the base resolution of the thing. It's not just the amount of memory, but as you start using more memory for these data structures, as you sample around them, they're not in cache as much, right? So you do a lot more cache misses on the GPU, because they're just not available, right?
If you sample randomly. Mm-hmm.
Well, so, I mean, this is something that I haven't looked at in detail for this one effect. So that's a little bit, but, so generally, we're rendering at 1 pixel. And so if you're going to cast, there's things you can do about all this that I'm going to say. I'm just going to say the super naive version. You can do pre-processes where you batch things together and compute things and store them and come back to them later or whatever, right? But if you're just going to like walk a long array through space and sample this grid, that's a lot like if you know the old line drawing algorithms like Bresenham line drawings and stuff, where you would draw a line by you have the endpoints. It's like a classic thing that you learn in computer graphics class because it has to be like perfect, or Bresenham's algorithm is perfect in the sense that it's not subject to any kind of mathematical error or anything. And you do it within limited integer word size computation. And you do it by saying like, okay, we round our vertices to a certain amount of subpixel in the beginning. And then that's a slope, right? Like, the slope of a line, as you learn in like school, is like the y divided by the x, right? But so how do you walk along that precisely with limited precision numbers? And it's like, well, you quantize and then you represent them as a fraction, but you never actually do the divide. So if you have a fraction on one side of the equation and a fraction on the other side of an equation, you can multiply by the denominators and then you don't have fractions anymore. You just have really bigger coefficients. And as long as you have enough word size to do that, you can do the same comparisons that you would have divided, but you don't divide. This is like you can look it up. Everybody can look it up. It's one of the classics of computer graphics. But so you can do something like that when you're traveling through a 3D grid as well, straightforwardly. But then you're just visiting, like if you shoot a line through a grid, there's no cache coherent representation that's going to keep all of that in cache, unless there's some really solid prediction machinery in the hardware about where you're going to read next, right? Which I don't know what's in GPUs these days. Maybe there's something like that. But it's not. So you can imagine the opposite, which is like I have a very small texture that completely fits in cache and nobody cares, right? Like because it's so fast. And so just these problems that you have when things get big, right? Now, actually, okay, all that said, GPUs do have a little bit of behavior with respect to cache than CPUs do. It's actually not as bad in some cases because shaders do a ton of math and they can be very deeply pipelined, right? Like this is the whole thing about shaders is they're tremendously more parallel than a computation your CPU would tend to do. And the programming style is a little bit different. So like you basically almost never do a dynamic branch inside a shader, by which I mean, okay. So if you write CPU code, you could think of two kinds of branches, right? You could think of one that you always do because it's based on either a compile time variable or it's just a go-to, right? And CPUs are not really confused by that because, they're scheduling instructions in advance of when you run those instructions and they can see the branch. They can see that it's definitely going to happen. And so there's no, it doesn't have to speculatively waste resources about what if we go the other way in the branch, right? We just always know we go there, right? So now branch prediction, right, in CPUs is about, okay, what if that's a dynamic branch on some variable that's like defined inside the function as a return value of something else? We can't really know what the value is. We could maybe predict whether the branch will be taken or not based on the past history of the branch, right? So CPUs have that in them, but it's more expensive to do a dynamic branch than a static branch for this reason, right? Both because the branch predictor has to kick in and decide which way it thinks you're going to go, and it could be wrong, and all these things, right? Okay, so on a shader, there's sort of 3 classes of branch, right? One of them is the fully static branch that's like a go-to or whatever. One of them is a branch on what we call a uniform, where a uniform is a variable that does get configured at runtime, so it's not like in the executable, but it basically doesn't change for a long time. Technically, it doesn't change during this entire render call or whatever. So it's effectively constant for the lifetime of like while these shaders are going to do their thing. And so that's also pretty cheap because you can make predictions based on that and whatever. Fully dynamic branch is then also less necessary because a lot of the time you can do what you wanted to do with a uniform, but it's also just a lot more expensive. And so you stay away from that in shader programming. And so the algorithms tend to be a little bit different. You tend to do a lot more things that work really hard to avoid dynamic branches. Oh, by the way, let me just notate all of this by saying, I don't even write shaders almost ever. So everything that I'm saying here is my high level understanding based on like, trying to think intelligently about the decisions that we're making in planning the game and all that. Like, I don't actually do this. I program all the time, but I mostly write CPU code, and it's often either on the compiler or just the gameplay system of this game, because it's really complicated and also because that's the best way to design a game is instead of like a lot of designers have a problem where it's very slow and frustrating to design because they have to communicate all the ideas to a programmer, and that communication is imperfect and it takes a lot of time to have these communication cycles. So if you're a designer who can program, that's way better because you can just type in the ideas and that iteration is a lot faster. So so if I say anything that's slightly off or whatever, it's because I don't actually write shaders.
Oh, you
This
can
is just
count
like
a ton of
neighboring
comments.
understanding.
Ton of comments like afterwards, like peeking all the details, like that actually not work. Like actually, like this has happened last time. I think it's gonna happen this time as well.
Yeah, I'm sure.
This was all the tangent from the question, like how the game changed over time, and this was the visual.
Oh yeah, that
changing
question.
And the fog and density and like all of that.
So so technical features like that, we had earlier versions of them, but then they became a lot more. Even better or worse is a relative judgment, but they became a lot more suited to the game we wanted to make as we figured out the game. And once they became more usable, we were able to make more beautiful levels with them, which helped the style solidify, right? There were a lot of, so how do we start, right? We tend to have high level directives in the beginning. So for example, it's a puzzle game where things occupy grid squares. And one of the things that frustrates me about other games is when they'll like add art, but the art makes it hard to read the level and understand where the walls are, where you could walk, what are the important interactive objects in the scene. So whatever the art style is in detail, we want it to meet all these constraints, right? Well, there's a lot of ways you could satisfy those constraints. And so part of the process is like, we kind of know generally what direction we're going, but we're also exploring at the same time. So one example about that also we figured out in the last year is like with water, that was a whole thing in this game. We did the water so many times, just trying to figure out how to make it look good and also be controllable by artists, and also, just be readable and nice and all this. And so we eventually did like our 5th or 6th water implementation is like this Fourier transform algorithm where you do these manipulations in frequency space and then you do the Fourier transform to generate the actual waves. It's a relatively new thing. I was skeptical at first just because like I think that kind of frequency space algorithm is very good for analysis, but for synthesis I've always been like it's just hard to get good looking things that way, but for this it was great. And then on top of that we layered some stuff, and so that gave us nice waves, but then we wanted the grid squares to be very readable, and so that was a whole like, do we use noise functions and we mask them? Okay, that's a little computery feeling. There's not enough artist control, and so what we have now, we have like a flipbook animation, which is like 64 128 frames, something like that, where we play little foam motion. And then that can be selectively masked with like something like the artist can paint like which parts of the water should have gridding and which shouldn't, which helps it look beautiful, but also because if you just have like a hard grid everywhere, that just right? But you want the gridding, especially, so there's some levels where I need to know, is this 7 squares between this shore and this shore? I need to be able to count, right? And so we provide that ability. Oh, but the thing that pushes it over the top a little bit is, we also have that affect the height of the perceptual height of the waves in terms of how the lighting is calculated, right? We do like normal mapping that is also tied to that grid and that paint. So like, it's not just like foam on the surface, but like the waves will crest around the grid lines and stuff and affect the lighting and all that. And we can do more of that effect or less of that effect on particular levels, depending on just how we want that level to feel. And once we did that it was like, all right, the water's really
How
good.
the tooling looks like for it?
I mean, that's part of what we were doing for 10 years, right?
It seems
I mean, I
like
could screen
this-
share some. I did that on another. Do we want to do that kind of thing, or?
If you want to do
is-
it, then sure. I would love to see it.
Okay.
You can do a bit of a screen sharing session.
Oh, you know what? Okay, give me a minute. So here's the thing. We have various builds.
But if you want, you can also send me like screenshots afterwards, and we can overlay them.
Yeah, I'm gonna make a build with debug shaders, and because we use LLVM for optimized builds, it takes like 90 seconds. But we could run that. I mean, it might be just a fun interactive thing to do.
I thought it's gonna be Lambda Conflex with 300,000 lines of code compiled in 2 seconds.
Well, it does. So debug builds are in 2 seconds. The thing is, because we have limited resources right now in terms of programming power, we do not have our own optimizer on the back. It's something I've wanted to start because it's not that hard to do. Like the thing about optimizing code is it's really hard if you're trying to meet like a state-of-the-art performance number, because you've got to implement tons and tons of optimizations, and they're all pretty fragile, and it's easy to make bugs and all this stuff. And nobody wants flaky compiler bugs when they try to optimize their code. That's terrible, right? So it's a big job in aggregate, but doing some of the job is not that hard, right? But we don't do any of the job right now. And so when we want to do an optimized build, we use LLVM. And so LLVM is just really cumbersome and slow. It didn't used to take this long to optimize programs. Now it does. It's actually easier to optimize programs than it used to be in terms of how much work you do. Because, for example, like CPUs used to not do out of order, execution or anything. And so instruction scheduling was very important in older compilers, because your program could run faster if the instructions were set up in a certain way, right? And then nowadays, or I guess it's strictly, what I said was not quite correct, but depending on how out of order you go, and how many execution units you have to bring to bear and all this, and whether your chip is like decoding stuff in the future or not, right? All these things matter. Well, like compilers used to do instruction scheduling. That used to be a thing that you would learn in compiler class. Nobody cares about instruction scheduling now. It's just not a job that the compiler has to do. So that kind of makes it easier you deleted an entire sub-discipline of compilers, but for some reason, just like all software, they just get slower and slower over. Although actually, to give LLVM some credit, it was depressing because we integrate LLVM in the compiler. We would update it every few versions and it got slower and slower like every time for what to us was equivalent functionality. The last couple builds have been on par or faster slightly. So they've decided this is a problem. They've turned the train around at least a little bit. Let us give them credit for that. It's still horrendous amounts of code. Like, you know, we have in a little side source tree for our external dependencies, we have like LLVM of the version we're using checked in, and like it's 99% of the source tree of our compiler, right? It's like incredible. So there's all that, but yeah.
I wanted to I reached out to Chris Lattner to do like Jonathan and Chris Lattner chat all together.
I don't know if we think about things similarly enough for that to be good.
Well, we would then like realize, or like it's not like, it wouldn't be a debate. It would be like a discussion.
Yeah.
And I think it would be nice, but maybe 2026 is the year.
Yeah, maybe. I mean, so the thing is, yeah, so right now, because the game is the priority, I'm not doing super heavyweight conceptual stuff on the compiler right now. It's mostly fixing bugs or things that, like, there are design decisions we made a while back that's like, yeah, this should work a certain way, and when I get a little bit of spare time, I do those. But like, then once the game comes out, we'll be back in like a heavier hitting mode in terms of language features, and that's when we might do that optimizer and stuff. And we have some ideas about parallel programming that we want to do and stuff. I could show some of the tooling in the game if you want.
Let's do it.
All right, I'm going to do a screen share. Window, this one. Let's share system audio. I don't know if I might have it muted on Windows. All right. So maybe people can use it. So, you know, this is a relatively simple level. Hopefully everyone can see. It's like a rectangle with some objects in it. And so one of the things the art team just makes it beautiful while keeping the core level readable. In a lot of levels, the background matters more.
The audio in the game is like way louder than
Way loud. Okay. Can I turn that down on my end in the Riverside?
Yes. If you were on the Riverside, I have no idea, and I guess not. But when you you share the window, you have like share audio.
All right. Let me turn down my Windows volume because we don't have an in-game volume yet because it's in development. If that doesn't help, then I'll just reshare without sound. How does that sound? All right. So I'm trying to open the volume mixer in Windows, and it's okay. It's under. All right. So I just turned it way down.
Okay.
How is this?
It's still loud.
Still loud. Okay. Well, let me bring it back without audio because apparently it's an open problem in computer science how to make things the right volume.
Exactly.
Okay. Share.
Audio and Bluetooth connections and everything.
Yeah, exactly. Window here. Do not share system audio. All right. So now I'm moving around. How's this? No noise?
Now it's good. It's good.
Okay, great.
No audio.
So this is a very simple level where we just do a lot of background art. A lot of other levels are more, you know, a little geometrically more complicated, but a simple level like this is a good start. So like this is the editor. I just press F11 to drop into the editor. This is like a palette level, which is just like gameplay objects that we would often grab. So like here's characters and here's some objects that are in the levels and stuff, right? I can hit Control L to load the level. It loads pretty fast. You know, I can zoom around it. I can, you know, I can start grabbing stuff and messing around with it. So if I decide I want 5 copies of this plant right here, I can do that. I hit Control F11 and it runs that in the game, right? So it's a very fast iteration cycle. Now, when we design levels, it doesn't look like this, right? So when we design levels, it looks like, actually, let me It looks like this. So, and you know, here, this is just like, I'm setting up a level where it's supposed to be interesting for this guy to push these little crystals around. There's some walls, there's some floors. You know, it's of course very easy to move these around. It's not as visually focused, but like, if I want to create some more complex collision architecture, right, I can just do that. And so there's a difference between how things, you know, I have arbitrary undo, redo, and all that. There's an entity system. It is not an entity component system.
Entity component ECS mentioned. Let's go.
There's an entity system that's a descendant of, like, I do a similar version of an entity system every game, but a little bit better every time. And so you can select like this. This is a class guy, or whatever you want to call that, entity type guy. We've got an ID. We can explain what the IDs are. This is actually an interesting question, is how do you do a game with millions of files where everybody, or with millions of, or how do I say, how do you do a game with like this level of scene complexity that we just saw? You know, this level of scene complexity across 1,000 levels in a big overworld, and not have like source control conflicts all the time and people locking files and stuff. That's like a whole thing. Fortunately, that we figured out very early in development. Anyway, so the levels start looking like this. Obviously, this is a pretty simple one. And then the art team gets a hold of them and makes them look more like this. So the collision stuff is still there. It's just like invisible. So if I hit this, you can see like, okay, here's actually the floor. You know, here's this wall, and we made it bigger than it needs to be for gameplay purposes. But sometimes when we mock up levels, we're like, oh, we want this to be a big cliff wall, and so we make the wall. This only really needs to be 1 high, probably, but yeah. So that's what the process is like, is to take something that looks like these brown squares and turn it into, you know, this. There's a lot of tools that we have. I showed this on some other surfaces, but so I don't know how well it's going to work here. We'll find out. If it doesn't look good here. But one of the core techniques that we use to make things look better is like this vertex paint technique, where we paint different, basically paint in colors. Like, okay, the history of graphics programming is that graphics hardware was very, it's like the readmes, right?
You have your 3-hour video on this.
Yeah.
Like,
well, it used to be very very constrained because the hardware was very simple. And so it was like, well, at first you just pass this RGB with an alpha color, and that gets multiplied by a texture or something. Then we get more and more complexity, but it's still traditional to have this like 4-channel color that you use as a mod, even though it's like not totally necessary anymore. So let's look at this for a second. And I don't use this interface very much, so I can, well, actually, let's use these. I've got some key bindings for this. I'm just looking for like the paint channel, if I can find it. It might not be bound to one of the keys. Anyway, so what I'm trying to explain is, oh, here we go. So we paint into these channels in kind of this low res way, these different colors, and the colors control the mixing of the channels. So the red means one particular material, green, or down here we have a floor material, right? So here, right, it's something with dirt and grass and whatever. And when we paint red, it means one blend. Let me get back to that. When we paint red, it means one blend, and green, it means another blend. And you can see it's actually this kind of artifacted thing sometimes, but it actually kind of comes out okay. So if I'm going to experiment, let's see how this goes. So I'm going to open the little paint panel, or actually first I'm going to select these entities. I'm going to open the little paint panel, and I don't know, we could just paint. Yeah, so here I'm changing the surface to be very smooth, right? Yeah. Let me turn off the wireframe. I'm changing the surface to be very smooth where I paint it, and that's one way of getting variation, but you know, the different colors probably mean different things based on how the material is like programmed. Oh, I don't know. Maybe it's just smoothness on this one. I don't know. But let me load up. we had a cool example that came up yesterday. So let me go back to that. Let me see. Where was it? Yeah, it was these materials down here. So this is a really like visually evocative example of what you can just do with this kind of technique. So like if I select this stuff and like I paint into the red channel, it like makes it this older distressed wood, right? And if I remove or maybe I just right click, I don't, yeah, I right click to remove that. And so this gives you a simple way that's very artist controllable, because you can also, I don't remember the keybinds, but you can like change the size of this little circular paint spray and stuff. But you can have some meshes and textures that, of course, you want a variety of those to provide visual variety, but then you can have hand painted visual variety in a very controllable way that enables you to be artistic, right? So if I select all of these, I could say, well, you know, a lot of people come step on this thing, so I want the area around it to be more distressed, and then the pathway that people walk, and then I want everything else not to be. So, whoops, I'm fumbling, I'm fat fingering. So you could clean it up and then be like, well, you know, we want this pathway that, oh, I didn't select those. I only selected here, but like, okay, we want this to be like that. And then if I go back and select these, I could like make this path go this way and stuff, right? And it's very, you can see it's very quick, and it lets you do stuff that's like very, matters a lot in terms of how the level looks. And so that's part of what we were doing in all this time, is like building an engine that has these features. There's a lot of more basic features that you would expect, like, you know, I can scale things and move them around, and I can select a whole group of stuff and move it around and copy paste it, and you know, so all that good stuff. But this is kind of like table stakes, right? And then a lot of what you end up doing is more custom to your game, like once you figure out what the game is.
People in the chat are shocked that this runs better than like Twitch tab in web development world.
I mean, you know, that's the thing, is so people like me and Casey and Sean and other people who have been educated in the game industry, right? We have this picture of how fast computers are and how much they can do. And this is also a thing you can discover from first principles by multiplying together what's the clock rate of your CPU, you know, and et cetera, right? How many execution units does it have? How many cores does it have? Like Casey would go down that route, but like, I think multi-core programming is kind of hard. So even just for one core, right? But you come up with very high numbers when you do that. And then you say, how long should it take to, you know, word wrap some text that's going to go into a window or something? And the answer is not very long. And we've just been in this spiral where software just gets slower and slower. And so people who are, you know, I'm obviously quite young. I'm very hip. How do you do, fellow kids? But, you know, people who are obviously younger and have less experience in the history of computers are mostly running software that's very slow. And so they learn how fast computers are experientially by running the very slow software. And so then that sets expectations. It's like, oh, of course a web page like can't scroll smoothly. What are you talking about? There's all this text on there. There's like 40 lines of text on this web page and an image. You can't possibly scroll that smoothly. And those expectations are set because that's what software is like. And then you have generations of engineers, most of whom don't try to exceed those expectations because they don't think they're realistic. And then someone like me or Casey will say, this should go 100 times as fast. And we get yelled at because those engineers know from their life experience that it has to be slow. So yes, but some places in games, we still try to make things kind of smooth, is what I would say about that.
Do you have a good example to showcase the water
yeah, let's
shader
look
and
for a
water
level.
tools?
These are, okay, so this might be a little bit of a boring level in some ways. I think it's fun because we have stuff in the background that we just sort of put
Oh.
messily up there, but then it reflects in the water and looks cool, right?
Nice.
But so this is an example of the grid water. Sometimes the materials aren't set up in the way that I expect. But so, okay, so because there's a reflection here, let me run this in gameplay mode. Because there's a reflection here, you can notice like there on the north side of the screen, you see the orange exit north of where my player is. If you look east of that, where there's just like a lot of dynamic range, and there's like dark parts of the reflection next to light parts of the reflection. Let me, this up here behind where the cursor is. That's where it's easiest to see what's happening, where you've kind of got these grid lines, and then the brightness and darkness of the reflection is sort of moving along with the grid lines as it animates, right? And that's because, like I said, this is affecting the normal mapping as well as just drawing the lines and stuff. And so just like that vertex paint thing that I showed you can affect like material properties, here we can do the same thing. This is one of many tools, by the way, but it's one of my favorite ones. So you can go over here, you select the water, you could be like, I want it to be, I guess we're painting roughness right now. So I want water to be rough right there. What's green? Green is, I don't know, some other, that seems like some other flavor. Maybe it's two different frequencies. Blue is like something, I don't know. Is alpha grid? Yeah. So with alpha, I'm controlling the strength of the grid. So like I'm right clicking and erasing grid. Like let's say I was making this level and I was like, it's actually for gameplay really important to have grid over here. Let me turn off this is like note entities that we put in levels, so I can turn off that text. So if I'm like, look, it's really important to have grid over here, I can just control that, right? And I can paint that out, but it's still this animated effect that, does all these things. And so, well, maybe I want it to be a donut. Maybe I want really strong grid, but then a hole in it, right? And so you can just sort of do that. And then if we go back to this view, these are all the things that I painted, right? And this is the data that gets stored for the level. It's for most meshes these days, I believe it's per vertex data. In the old days, we had two modes. We had textures mapped onto the things and we had vertices, but I think for the most part, it's all vertices now.
Nice.
But like, that's just
and the water
examples of the tools.
On the board in the middle, on the board tiles are also the same way, the vertex painting.
Oh, you mean the paint that I was talking about?
Because like
these
the
guys.
southwest of the board is overflown, right, with the water. This level of water.
Oh, that's actually not what this is. This is like a different thing. This is a different material that's more technological and mechanical, but it's not supposed to be water. I see how it could look like that, but it's actually still supposed to be above the water.
Okay.
What this is a
this is
kind of energy disruption effect that the way these tiles are being created via matter projection is like falling apart. That's why there's like a rainbow effect and stuff. But this level was, in the game, you would see that on simpler levels that don't have water and your brain would parse it. But yeah, on this level, I see how it could look like the water just overflowed. But that's not what it is. But yeah, I don't actually know the specifics of all these. Okay, so here I'm painting it and it's becoming a little bit darker in hue. Let me select all these again. Whoops, I dragged it. Yeah, so you have
yeah, I can see the
per material you can configure the material's responsiveness to these things. So yeah.
Will there be modding tools released with the game?
I mean, initially we're just really concerned with getting the game done, right?
Okay.
So, but you never know. If people are enthusiastic about your game and want to play it in certain ways, I don't mind helping them out a little, right?
People in chat seem to be extremely enthusiastic about this level editor and
yeah, it's fun. I mean, it helps tremendously for the quality of a game if it's just easy to make things. And that sounds obvious, right? But then, people kind of underinvest in tools, or, you get an engine like Unity or Unreal where there's actually been a tremendous amount of evolution on the tools, right? However, like that evolution has gone to making general games and not exactly your game. So often you'll have these tools that have a tremendous amount of work put into them, but they still don't do really quite what you wanted. And then if you have a source license for those systems, which most people don't have, but if you did, it would still be hard to go modify those tools because they're so complicated, because they're meeting so many constraints from so many. And so part of the beauty of having your own system is those problems don't arise. Like if we decide that we want to go do something, we can just make it do that. And it's not at all unreasonable. I'm wondering, should I pop open some other panels or something just to show some other stuff? So each one of these buttons is like a different thing. We made a little material browser for some reason because like the art team wanted this. I actually don't even remember how you drag around in here, but I can like move around this view somehow. But like you can like browse the material hierarchy and you can see what it looks like mapped onto a sphere and stuff. Is that useful? I don't know, but it's a thing. I think the art team did really want it, so it's a thing that we have.
Is it?
We've got like, it's non-trivial to make all this stuff happen, right? So
yes. And this
UI,
partly...
somebody's going to ask about the UI. This started as a descendant of the UI system from the Witness, which Casey actually worked on. But then some other programmers changed it, I think, in a way that Casey wouldn't like, and I also didn't like it. So then I started with the UI that we have here, and I was like, let me make a system for anyone using the programming language. And it would be funny if it's called getRect, as though it were a function call for like getting a rectangle. And so we actually ship this UI system with the compiler now, and so everyone can make cross-platform UI. It's not the most beautiful most of the time, but it actually can be more beautiful than this. Like we give you the facilities to set all the colors. It's just we don't always do it ourselves, right? But so that's what all this is. Obviously, we don't work that hard on the button icons sometimes, right?
And getRect spelled with the C. GetRect.
Yes.
And also the getRect uses an underlying module simp. Obviously,
that is true. They're actually a little bit orthogonalized. It'll use simp by default, but you can like plug in. So that was one of the questions. Okay, so getting back to programming language stuff, one of the questions that we have is like, what can you do about this kind of dependency hell that everybody gets into, where like, in theory, programming languages give you code that's reusable and redeployable in different contexts and stuff, but in practice, you want to use certain code and it's tied down by like a bunch of other dependencies, right? And then those dependencies are either not things that you want, or they fight with your code, or they make it longer to compile. And so it was an interesting exercise that I think we've gotten a fair way. Actually, if we want to stop showing graphics are nice, but
do you want to end the
I might
screen
share,
or do you want to show
I'm going to
show the
stop
code?
sharing this. I'm going to share my Emacs. If there's something Riverside is doing or something is doing where now windows aren't popping up normally. So if I look a little bit confused sometimes, it's because like what is happening is not what I expected to happen. Okay, so this is simp actually right now. But actually this is another, so simp is meant to be a very simple graphics API where like, look, I just want to run a program. I don't want to know about anything about graphics APIs. I just want to open a window. I want to draw some rectangles, maybe with some bitmaps. I want to draw some text and all that. It doesn't have like UI widgets or anything because it's supposed to be simple. But by default, because we don't want you to think about the API, it has to use some API to get on the screen. And so because GL is pretty cross-platform, if you import it's a module as contrasted to like a library in C++ or whatever. We use that word because I thought you need to use a different word than libraries because especially if you work in games, you'll end up linking against libraries that are in C++ that are written by other people. And those are like a fundamentally different thing than this. This doesn't get built into a compiled representation that you link against. this just gets compiled along with your program every time that you compile your game, right? And that gives you a lot more flexibility, actually, and it means you don't run into all these like link time error problems that we all love from C++ and all that. But anyway, so this module parameter says when I import simp, then by default, it'll use OpenGL, but I can give you a different API. And right now they're actually hard coded, but as we've been evolving this idea, we can go to GetRect, which you were talking about. And here, this has a similar thing, but this has a thing called the type indicator, which is a compile time class or whatever. We don't really use that word, but it provides a bunch of things because so GetRect, it's a UI input system. It needs to draw the widgets. It needs to read input, right? It needs to do a bunch of stuff, and every operating system probably has some default way of doing that, but you as a person with your own user level program might be opinionated about that, might want something else. And so how does it do this? And so if you provide a type indicator, it'll have all these functions in it, and they're not even callbacks. They're like static functions that get resolved at compile time, I think. We'll double check if that's true. But if you don't, it has a default value of void, and later on we detect void and say, we'll put the defaults in. So when you import it, you can just provide all the defaults with this one parameter. So it's like very, very clean. So if it's void, then we say, hey, we're going to use simp to render. We're going to use this window creation module. You sometimes need, like if you're going to render text, the user needs to say render text with this font. But how do you do that if the definition of font could change? In C++, the answer is, well, you included some different header file with font. And there's all sorts of messes that could happen with that, right? That experienced programmers have handled. Here, it's just font is a type. This is a little more, so some of the inspiration we get is from the functional language side of things, in the sense that this is not at all a functional language. It's a systems programming language where you do lots of side effects and you manage your own memory and stuff. However, there's a certain cleanliness to it. That's the same kind of cleanliness that you would get historically from some of the functional languages. And so font is just a type, and it could be whatever, but regardless of what type it is, it's the same size as a parameter as you pass it around. There's certain things you don't have to worry about. Okay, so if you don't pass this, which most people probably don't, you get these things. So simp has textures and fonts, and so we use those. Otherwise, we get whatever you said. And so we could look at, so what's funny about this, I brain spaced and I was looking for the definition. The definition of this is whatever you provide. We have an interface thing, so we actually could have said interface here, but we don't do that here. So there's actually not type checking on whatever you pass as type indicator. It just has to have these members. And if it doesn't have these members, you'll get a compile time error. In some other, if I remember which modules we use the interface thing for, because this is all ideas that are in development, right? There's an interface version of it where it'll make sure that you have these members of these types or whatever, and you'll get an error when you import. But the point being, though, if you're from the C++ world, you have this model that like you use code by including the interface for it as text. And that's not how this works at all. This is like it compiles separately, and then you pass it some data in a well-defined way that defines the things how you configure it. And so it doesn't make your program messier to use modules in the way that it does in C or C++ when you use libraries. That's one of many advantages. But yeah, to get back to the point, we're trying to provide this flexibility. Like if I don't want a dependency on simp, right? Or if I want to use a different like module or whatever for opening windows or for reading input, the input here I think is tied to one of these other modules. Oh, no. Okay, so I lied a little bit. We actually do take this dependency explicitly, but I'm like, we should put this in the type indicator. I just haven't done that. But that's the point, is like you can, if you're thinking sophisticatedly about dependencies. So first of all, I think fewer dependencies is better, broadly speaking. But then also, for convenience, you kind of want dependencies because you don't want people to have to be rocket scientists to use your code. Even to begin with, it's a good pattern if like it's easy to use your code in the beginning. I don't have to think about it. And then as I get used to it and how it works, and I develop more of an opinion of how I use it, or I even like when I start using someone's code, I don't even know if I really want to use this. Maybe it's trash, right? So how much like it's kind of pompous to expect somebody to invest a ton of time and energy to even decide if they want to use your code. Because when you're on the other end of that equation, it's like, I need to solve a problem. I have a certain amount of time to do it. There's like 375 potential packages on the internet that claim to do these things. Most of them are bad. Most of them don't really do a tenth of the things. Some of them are good. Do I believe people's opinion? Do I ask ChatGPT which of these are good? Like, I don't know. And then you start trying to figure this out, and then you greatly appreciate it when it's easy to figure out. Like, can I compile this thing easily? Can I run it easily? Can I use it easily and figure out what it does? And so you want to make it very easy to do that, which means the dependencies that you actually have to take, like, look, it's an input widget. It has to read input. It has to draw stuff on the screen. You want to make that as seamless as possible. But I think the problem that languages, you know, like JavaScript fall into or whatever is that then, I mean, they also invented the words dependency injection, I guess. But nevertheless, there's this culture of like, we just take this dependency by default and you can't do anything about it. And so software just grows monotonically, right? All of this also actually goes to really, so these are kind of, what would I say, more, they're less core stuff. Like you can of course run a command line program that doesn't have a user interface or doesn't do any input output, and it doesn't need to use any of this. But most programs are going to use some, like in C, it's like libc, right? In fact, you have to use libc if you're on Linux. You have no choice. On Windows, you actually don't even have to use libc, but almost everybody does, because that's how you like print strings and whatever, read files and stuff. So we have equivalents of that. It's more broken up and much more modular. And so this is a module called basic, which is like, import this if you just want to do a program, and it's going to be a little bit thrifty with dependencies, but it's going to import a bunch of stuff like printing and time and like float conversions and array and memory allocation is actually included at a layer below this, but and then you have some configuration you can do about how you want this stuff to behave, but it tries to walk a line between being very convenient for people who don't want to think about dependencies, but also not unduly saddling you with dependencies. But then, so within this, all these dependencies, okay, this is maybe one of the things that use the interface thing. So here, you might turn on memory debugging, which is the stuff that I demoed at LambdaConf, where we have these visual clients and stuff. And so there's a whole set of hooks in here. And so how hard-coded is that into the system, right? If I import basic, and so first of all, I don't have an alloc function at all if I don't import basic. I could choose not to import basic and define my own, and that would be fine too. But if I do, then do I want this memory debugger? Do I want my own? Do I have hooks for that? And the answer is, there's several options. Up here, when I say, do I want the memory debugger? I say I either have a default one. It's not void in this case. It's like this thing. So the reason this is done differently is we have a relatively new language feature, which is most of the code in this module will not compile until you provide these options, because you need to know what code to compile. There's the equivalent of if-defs and all these things. But anything in these braces gets compiled before that and doesn't depend on these. And so in older versions of the language, we didn't have a way to define the interface that you would comply to when you pass the parameter, because anything in the module would compile after the parameter was supplied, if that makes any sense, right? So here it's like, this compiles no matter what. And then, so if you're going to supply a memory debugger, it has these functions. And again, these are not even callbacks because these are constants. So they get resolved at compile time, which is not really quite a thing that you have in like C unless you do shenanigans. It's not, because the C sharing model is textual, you kind of have to have a lot of textual pollution to do that. And I don't think most systems do it. But it's faster to call a statically determined function than it is to call a callback, broadly speaking. Again, that's a general performance statement that you should evaluate for yourself. So this all works with like statically determined functions and stuff. And so if you don't provide a default interface for the memory debugger, but you say you want one, you get this thing. And these are actually, in the struct, these are just function stubs that are defined. But down here we say if it's the memory debugger interface, then we have some functions that we use, right? Otherwise, we use whatever you passed. So you get a large amount of flexibility in a very clean way. And basically, so to get a little bit more concrete, right? The function alloc, which itself can call a different allocator on the back end depending on how it's called, right? It calls this allocator proc with, so the C, this is a little bit like what happens in C, actually. I guess this is not part of the interface in C, right? Like the user level interface, but the convention is generally that there's one function that could allocate and free and do a bunch of stuff. And then you just pass it some number of parameters that say what activity you want to do, what's the memory and all that. And so we have that kind of a model, and that makes it a little bit convenient because then an allocator, instead of being like a whole bunch of function pointers, is just one function pointer, right? And it's just easier to move it around, or just to think about it. Even like if you want to supply a replacement allocator, you write one function that does these things. And then if, this is like an if def in C or whatever, but if memory debugger, or it's like an if in C really, but different, then we'll call this, right? And this is a thing that you define that's again a statically determined thing, and then we'll call the check function on that. And so these hooks are in BASIC. If you wanted to hook into memory debugger from your own replacement for BASIC, you could do that. It's created to be very modular and flexible, like way more modular and flexible than C. Like in C, if you don't want the dependencies, which I'm sure some of these people are in the audience, there are people who don't want to use libc because it's big and bloated and ugly and does a lot of bad stuff. So they're like, I want a minimal executable that only does what I want. In C, you kind of only have one direction of that choice. You can burn down the stack that you could possibly use, because once you're not really using libc, that rules out a lot of other software that like wants things to work in a certain, maybe you could re-implement some things that are compatible for the dependencies you want to use, right? Here, it's not just one linear burn down like that. It's like you have a little more choice about what you want to use and what you don't want to use. Maybe this is too abstract of a discussion and we should cut it off there, because if people don't know the language, they don't know what they're looking at. But
I feel
whatever.
like the large part of the audience, at least the live audience, might be in the beta.
That could
as
be
well.
true. We have 1,000 people in the beta. It's not.
I think almost
it's not that small.
2,000 now. If
No,
the
it's
Discord counts.
it's getting close to 1,100. Maybe a lot of people
Oh.
are sneaking onto the Discord who shouldn't be there.
Okay.
I don't know, but on the
Okay.
mailing list, there's around 1,100 people.
We can continue the beta discussion then, Jai beta.
Sure.
In terms of, there was initial plan to release Jai alongside the game. It was like, hey, I'm gonna
Yeah.
do a programming language
Yeah.
and sort of a game to showcase their ability and test it.
Yeah.
So what we have now, the release schedule for the game.
Yes.
What about
yes.
Jai?
Okay, so I will tell you my general plan as it exists in my head, which may change. This is not a promise. This is my general plan. So first of all, like the game is how we survive and make a living and all these things. And so the game is the highest priority. So shipping the game comes first. Now, once the game ships, what we want to do, and I don't think this will take very long, but we want to sort of cut down the source code to the game into a thing that we can redistribute as open source that is the engine plus a lot. It'll basically be a game, but just without all the gameplay mechanics and all the levels and stuff. Because you don't want, like, it's gigabytes of level data and all the art and stuff, and you don't want all that, but you want some art just because you want to be able to run it and have a demo level that looks good, and then be able to use that to evolve your own game, right? And so we want to give that out. And the question is, what does that look like? Well, I think we just published the engine as open source. That requires people to have access to the compiler to use it and to use all this other code that I've been flipping through. I think initially we just give out the compiler as a binary still for some period of time, just because that's easier for us, and it's like less drama and weirdness and stuff like that. But you know, eventually that will be open source as well. It's just how that is done. Like, if my concern is what is the quality of the development and evolution of this programming language after it gets open source, then I don't know, some things matter based on how it's done. Am I the benevolent dictator for life of that? I don't think so, because I need to make video games. Like, I need to design games and stuff. And so I need to have time left for that. And it just takes a long time working on the programming language as well. Okay, but so when do we at least do the binary release of the compiler along with the engine source and all this stuff? Not too long after the game comes out, by which I would say some, hopefully small number of months. It's a little bit complicated because there's also other stuff that you do after release of a game. You want to be very responsive to any problems people are having. You want to also start ports to other platforms. So it's not like we'll be doing nothing after the game comes out, but that is a major milestone that we need to pass. Okay. So there are some other dependencies though. So one reason why I haven't just released the language publicly is because we're still changing a lot of really basic features into better versions of themselves. And the problem is, once you release something totally publicly, then a lot of people's code breaks when you change stuff, right? And it's very inconvenient for a lot of people. And so we're trying to get to the best version of the language while removing all that pain for people. And not just that it's pain for people, but in reality, what that tends to mean is that you tend not to make these breaking changes anymore, right? And you end up with something that is kind of messy, like C++ that we're trying to get away from. So this allows us to evolve the language while not leaving this heaping bag of mess carried over our shoulder of the old features. And this is a little bit inconvenient for people in the beta. So they will know, like just in the past week or two, we actually turned one of the old the pointer dereference operator that we used to use is now an error.
Bracket.
Yeah.
Not the angular brackets.
Yeah. It was a very ugly operator to begin with, but like I didn't have a better idea at that time. We did it differently later, and that's just deprecated now. And so that would be a lot. This was a really interesting case. So we could go to the modules again, if people can still see the screen share. So we have a bunch of metaprogramming facilities in this language of the kind that I talked about in that LambdaConf video. So I won't go too deep into it. People can go look at that. But in that speech, I basically talk about the way this language views code as data and has a whole system for showing you what the code is like, and in an authoritative way. So if you want to modify your program with another program, you can obviously do that by rewriting the program text, but that's dangerous because your program that's rewriting the program text doesn't have as good of an understanding of that program text as the actual compiler does, and it could interpret things wrong and make mistakes. Like, just imagine you had a string with code in it, right? And it has to understand that that's a string and not code, right? And that sort of problem just balloons in a different way for any particular language. So when we rewrote this operator, we were like, let's use that as a test of this system. And this test didn't introduce or didn't exist in the LambdaConf timeframe. This was just done a couple weeks ago or whatever. It was like, let's make a plugin that you can invoke. So when you run the compiler, you can add plugins that add functions that run on your entire program as it gets compiled. This is all user level code. You don't have to have source code to the compiler to do this at all. And what this plugin does is, so first of all, it'll only overwrite your source code if you tell it to. So it's got its own command line options. By default, it runs in test mode. And what it does, it reads messages from the message loop of the compiler, which is exposed via a user level meta program. When it sees that code has been type checked, and the thing about code that's been type checked is you know the type of everything, and so it's unambiguous now what the meaning of this is. So any of these like syntactic questions like, is this code in a string, don't occur now, because you can just look and say, oh, this is a string. If I care what's in the string, I can look in the string. If I don't care what's in the string, I don't have to, right? And so it looks at this, it says, what are all the sub-expressions? Why am I getting the build options here? Is this? Yeah, I guess I was doing something that we don't need to do. So that'll be in the next beta, is deleting that line. But basically, we get these type check messages, and we look for unary operators, and we say, is it a pointer dereference that's been deprecated because the compiler is setting this flag on this thing? And then we just put it in some data structure. And then when it's time, we look over everything in that data structure, and we rewrite. I'll just flip through it really fast, but we rewrite all the files that used that operator. Okay, so the reason this is interesting is part of the reason this left less than sign is kind of ugly is because it's also, as you know from C, it's like the left shift operator, and that's true in this language too. So you have like left shift if it's used infix, and pointer dereference if it's used prefix. And like, so if you just string replaced it, you would mess up all your bit shifts in your program, and that's not good. So we actually go and rewrite the source code, keeping all your comments and formatting and all that. But just in the substrings we need to replace, we replace it with this other thing. And depending on, let's see how clear this code is. Depending on the situation, if it's like a very simple case, like it was this with an identifier and there were no parentheses around it, right? So if it's not this, even, then we just do a rewrite. So we would turn like, if it was like this, we turn this into x.star, right? If it's a more complex expression and all that, we actually have a prefix version of .star, and we just replace it. So we do slightly different things depending on what's the situation. This whole program it's like 300 lines. It's got a lot of comments, as you can see, but it's pretty simple code, and
I would like to emphasize this because like people might not realize this, that this is like a meta program that runs during the compilation. It reads your entire program source code, generates the AST, looks for the expressions and replaces them with the new operator from the angle bracket to .star, and writes
only
to
in the
source
correct
code.
places. Only in the correct places.
Only in the ones that are like genuinely, and you can know this by compile time, by their location in the AST. And this is 300 lines. Like, this is crazy to think of in like a C++ large code base.
As far as I know, no other programming language can do this, right? And, there are a number of languages now that have some sort of compile time execution facility, but for various reasons, that facility is limited in various ways. Some languages are like, oh, it's for security, which doesn't totally make sense. Like, I know why they think that, but that doesn't totally make sense to me. In some languages, it's just more like, well, it's just hard. It's really difficult to ensure certain aspects of language semantics and compilation and whatever if you can just like run anything at any time. But just like when I made this game Braid and I was like, let's just put rewind in and just figure out, not limit rewind a priori, and just figure out the consequences of that and figure out what the game design should be. For this language, it's like, let's just make compile time execution completely unlimited. Whatever pain that introduces, we will figure out how to deal with. And there was some for sure. There still is some stuff that needs to get figured out, but at this point, it's like mostly figured out. And then let's just see what you can do with that. Like in the beginning, it was just fun. So famously in the first live stream for this language, you know, well, it'll take a minute to screen share. So let me not. Oh God, I think it's because like my system is super laggy because the thing is like uploading video.
Yeah.
And so alt tabbing is never mind. I've also got the game running still in the. Let me close it. But the you know, I won't go run it now because it would be an extra screen share. But we have this like it's called Invaders, but it's really Galaga program that we ship to people. It's in the examples, so I think it's that. What is it called? Oh, it's in source. So there's a meta program for this too, but you know, it's just this program for like a simple version of Galaga, and it was really fun in 2014 or whenever that video was, a long time ago, to like run this. You would run it from the compiler, you would fight aliens, and it would only compile your code if you killed enough aliens. And it was just a really goofy thing to do, but it was making the point that like, look, you can literally run a video game that renders graphics from inside the compiler at user level. Now, that's obviously a powerful mechanism, right? But there's still a fair amount of distance to go from, okay, clearly you can have this kind of power. What is the most useful form of this power that is used in a structured way that doesn't cause your program to fall apart if you use it? So that one back then, so there's this thing that you can do in any program right now. You could say run, you know, print hello, and that'll just happen at compile time, right? You don't need a meta program. You don't need any kind of structure around this. That'll just occur. In fact, I mean, why not get real about it? So let's make a program. Let's go main. Oh, you know what? I would have to run this from Emacs to do the screen share. Let's see if I could figure out MetaX shell, right? So print, this is at runtime, right? We're going to import basic so that we can print stuff. And now at compile time, we're going to run print factorial of 5 is whatever. And of course, we don't have factorial, so let's make that. This is the bad version of factorial. This is a computer science school version of factorial.
Live interview with Jonathan Blow.
Yeah.
Like
okay.
Coding interview.
Yeah. Okay. Wait. MetaX shell. I never do this. Okay. Wait. So, all right. So that compiled. This is at runtime. But you can see at compile time here, before we ran the linker, we said factorial of 5 is 120, right? So this is just a very raw, simple example of compile time execution. A lot of languages can do some version of this in some way, right? But then all this stuff that we're talking about, like with the meta programming and like, you know, the way module importation stuff and the way workspaces work is all trying to answer this question of like, how do you have your program not fall apart and just be super messy and incomprehensible as you try to do more stuff with compile time execution? Because, I mean, this is fine when this is really small, but let's say this is like 1,000 lines. Like, so for Sokoban, for example, we have a meta program that does a bunch of stuff. This is literally it. It's 1,800 lines. All right. It's got a bunch of global variables. It's got a bunch of stuff. Most of these things should not occur in the runtime version of the program. And in fact, we're taking all these dependencies to like do stuff, right? If there's no differentiation between your compile time program and your runtime program, then your runtime program has all these dependencies, right? And so just as a way of keeping it clean and like what goes where and all that, we just started to architect how does this work. And that was actually a long process of discovery. So the plugins, which I showed, let me see, I think there's an example plugin that I can run. So if we go back and we do this, oh wait, I'm trying to alt tab, that's not gonna work. If I go back, go back to Emacs. Can I find my shell? What's the shell buffer called? It's like it's defocusing me from the window when I hit Alt. It's so confusing right now. Let's just run another shell. MetaX shell. I don't know how to get back. Oh, it's the same one. Great. Okay, so I think I can go. Oh God, how do I? Is it Control P? How do I go back in history and whatever? I'll just retype it. And I can go plus, which says add a plugin, and I think it's called example plugin. If not, we can go look. But yeah, there we go. So this is just a thing that verbosely talks about the messages that are coming through the system, because if you want to write your own plugin, you might look at this. And so I can run arbitrary code from the command line by adding the plugin here, and like, you know, it's just saying what's coming through the system. And even though it's a small program, there's a lot of stuff getting type checked because we're importing all of BASIC, which is like all the file stuff, all the print stuff, right? You know, even though this looks like a small dependency, like with libc, it's a substantial amount of stuff, right? And so, but that's like pretty cool that you can do that, right? And that it's that ergonomic, and that it's that structured, and that it works as well as it does. And so that was actually cool. So to go back to the rewrite thing, it was part of our thesis that, like, let's say we, even after the compiler becomes public and we want to make some semantic changes, like in theory, we could make those in a more smooth way than you typically could, because we have this whole system and we have this clear understanding of the program at user level and all this stuff. But it was like untested. It was like I was designing for that, but we hadn't tested that. And so this was the first test of that. It is somewhat simple. Rewriting a small amount of operator text with another one is not conceptually that hard. But it was, as far as I can tell, it was perfect. I have not heard any complaint. It worked on our 300,000 lines of code without any problem. And it didn't, you know, it took me like an hour to do this or something, right?
It's nice that you have like a 300,000 line project to test your stuff in with the new changes.
Well, and that's part of the point too, is like, so, you know, everyone's like, why are you making a new programming language? There's so many. Who do you think you are? And it's like, the thing is, when I'm working on a game, it's really hard to make games. I cannot overemphasize this. Games are really, they're always bigger than you think. They're always more complicated than you think. They're a tremendous amount of work to do. And it's hard. Like, you go through these crises in the middle of development where you're like, oh my God, did I really sign up for this? And am I ever going to finish it and stuff? And then you go, look, like, maybe I don't like C++. Let me see what people are talking about. And you look at what people are talking about. Their new language has this feature and whatever. And you're like, that feature has nothing to do with the problems that I have. The problems that I have is just that my programs are really complicated and they're hard to understand, and it gets slow. Once it passes a certain threshold of complexity, it just gets slower and slower, right, to make progress. And so I want things that help me with that. You know, people who make languages will be like, well, your problem is that you have global variables and that's making your program more complicated. And it's like, okay, first of all, yes, beginner programmers can make big messes with global variables. I even made a mess with global variables in Braid. It didn't matter till we did the anniversary edition, but like, you know, it wasn't great. But like, once you're experienced enough, you're just like, yeah, you use variables within the scope in which they're relevant. And then that's fine. It's not a problem. Like, you know, I don't need a whole programming paradigm to solve a problem that does not exist for me, right? And so you see all this rhetoric, and it's like, but I just want to help. I just want help understanding my program, right?
So this ties to my question about order of thinking star.
Yeah.
And how the dry meta programming features helped development.
Well, there's a bunch of stuff. And a lot of these are the ways that they help everybody, right? Because we're designing these things. So one of the things that runs at compile time is a thing that checks your code just to look for errors, right? And we modeled this after what are the kinds of errors that I run into. So just to go again, we'll go to modules check. This is a substantial amount of code that looks for things in your program that are sus and will issue warnings. But the whole point of this is you can replace this if you want with something else. You can augment it with other things. Inside the compiler, there's actually almost no warnings, because one of the things I was sick of from C++ land is like, it just generates a trillion warnings and you have to ignore a lot of them and whatever, right? And so, so here we'll just say, or sometimes we just hard error. So some of these are simple things that C++ compilers do now, but didn't used to do back in the day. So when I started learning C++, even professionally in games, if you made an error in your printf string, you just would have to discover that at runtime, right? And it makes sense that that would be true, because the compiler, the language semantics don't know anything about the contents of a string. A string could be anything and whatever, but this was such a widespread problem that C compilers started implementing a way to tag things as printf functions so that they can then do this parsing of the, because it was such a huge source of bugs. So we have the equivalent of that. In this language, the formatting is a little different. It tends to be simpler, so we don't have as many problems, but we have checks for that. We actually, I don't know. That's actually, I guess, the main thing that this does in the main file. There's some other stuff about like bindings that Raphael did where, you know, if you have like name mangling for a function that's in a lib and you claim, so whenever you're going to bind to external code, you have the claim in your programming language about the function that you're calling. Like, these are what the arguments are. This is what type they are. But that could be wrong. It's just like something that you typed. And the actual implementation is in some binary file that was compiled by somebody else, and you're linking against it. And you can link against it and not realize that you're actually passing the wrong arguments and stuff. And so we have checking for that, for example. Let's see. We do a bunch of stuff. So we control what build we're making from here. So this was, again, one of the core ideas about how we could use metaprogramming, not metaprogramming, how we could use compile time execution as a feature, and besides just running some invaders program, is like, well, if I have compile time execution, then I can use my whole language in my language. So like, I don't need to have a make file or any of that stuff. So this is the make file and everything, right? And so what happens is, you know, we look for some arguments about which build we want, right? And these are like callbacks that we go into based on what build we want. And so this is very easy to edit and configurable, and everybody knows this programming language, right? And it doesn't have weird pitfalls like make will fricking syntax error if you use a tab instead of spaces. At least older versions of it did. And you're like, what? It looks right. I don't understand why it's not parsing, right? So it doesn't have any weird stuff like that. You know, there's no like weird Python that only some people on the team know or whatever. And then it's just, it can share code with the target program as well, right? So when we go look at one of these, like if I'm going to do a release build, it's just a little, whoops, I jumped away from it. It's just a little function that sets some options and the name of the executable and whatever. And we have a bunch of these. Let's look at other stuff that we do. Okay, here's actually a pretty big feature. So in a language like C++, actually they have now sort of added better introspection to C++. I assume it's bad. I don't use new C++ features anymore, but they have something now, I think. But back in the day, there was this very, very limited introspection that you had called RTTI, runtime type information, that was actually useless for most purposes. And so, but one of the things, so you saw the interface that we had earlier where I could click on an entity and it's like, it gives me all the fields. Those are the fields. Like if I go into the source code, it's in the game subfolder. And I look, we clicked on a guy, right? Those were literally these fields from the source code. Here they have some annotations about what versions are these valid in, and should we display it in the editor or not? That's what, you know, that. Should we serialize it into files or not? And all this sort of thing. No serialize implicitly means don't put it in the interface. And so there's versioning and all this stuff that happens. C++ doesn't help you with that at all. At least it didn't back when I started this language. And so you would end up just for every type that you declared that you wanted to be able to serialize or have an interface for, you have some other function that registers that type, right? And does stuff. And you could have mismatches between the function because you're maintaining a separate thing. And all that. So the way all that works in this language, let's look at something else. So something else that seems different, and we'll show how it's related. So we have, I popped up the little console for a little bit and had some commands in there. Where is it? I never know what's in the game folder and what's not. It kind of doesn't make sense right now. We need to factor this more. But so you can define any function and you can tag it with a note like this. You could say this is a command, and it'll just automatically show up in the console. You don't have to have another function that also registers this thing with the console, and it just helps cut down on the amount of busy work that you have to do to make these things happen. And so the way these things happen in the metaprogram is, let's see which of these we see first. It's 1,800 lines, so there's a lot. Okay, so here again, this is the loop that we get, like in the plugins that we were looking at. There's a loop. We get messages. Here we're getting the messages from the compiler. That we get that. Here we're passing them to plugins. So that rewrite plugin that we looked at is called from here, right? We call it. But then we can do whatever else we want with that message. If we're done, we complete. This was just an old robustness test for the compiler. But then here's our actual function that we call, right? So here, okay, so this is that register command note that we saw. Here's where that gets handled. We're okay, if we see some headers of procedures, functions, whatever you want to call them, look at the notes. If there's a register command note, first make sure that we can parse out, because there's some details that you could tag on the end. And then we put it in commands to register, right? And then we make sure that we're not dead code eliminating that procedure, by the way, because we want the console to be able to use it. This actually might not be, it's because we parse the comments out of the body of the procedure, like Emacs style. Anyway, so yeah, if we go back to this for a second, this actually ends up, when you say help and the name of the command, it'll print this. It'll automatically read that out and print it. And so that's why we want to make sure that we see the body in the message loop before. So what we're going to look at next, actually generates the code that hooks those functions into the console as commands. And the function is definitely live after you do that because other code is calling that code. But we want to have this string available when we do that. And so if nobody in the program was calling it, we wouldn't, the body wouldn't necessarily get compiled if you're compiling with dead code elimination, which you may not be. I don't know. Okay. So commands to register, right, comes down here, and we sort it just to alphabetically, just to make it nice and consistent between runs, because this stuff is coming through a message queue asynchronously, so you get these messages in different orders sometimes, because the compiler is doing some stuff in parallel at least. And then down here we actually we check if you try to redefine something twice, but if you don't, we just do, this is just some regular string formatting where we're calling a function called add command with the name of the command and then some options and stuff. And we actually, these functions, so this one has an argument. We look at the argument list and we do, when you're typing a string, just a command string into a console, you might type numbers, you might type Booleans, you might type strings, and they're untyped, right? And so the thing that runs the command also does a simple programming language kind of thing where it parses the integers, it parses the strings and whatever. And so you don't worry about any of that here. I've definitely used command systems before where you did, but let's look for something that takes an int. Yeah, well, advanced level, well, that's that could be called from outside. Like set window size takes 2 ints, whatever. You can take whatever type you want here. Well, as long as it's one of the primitive types that our metaprogram handles. So we do all that. And then when we generate this, we pass those arguments. Wait, no, okay. So I'm skipping over something. So the binding for this add command has the pointer to the function that you're going to call. But we don't just call it with the raw string is what I'm saying. Add command adds a callback that parses the string and then calls this is basically how it goes so that you get structured data in the end. I would have to look at, it was a long time ago that I wrote this, but those implementation details are handled is the point. And then, so, okay, we talked about entities for a little bit, right? Let me, where is this? Okay, so we have this file called generated entity data where there's various things you want to know during runtime, like what are all the guys in the level, right? What are all the rocks in the level, whatever. And so we store entities in this data structure called bucket array, which is, a bucket is just some amount of contiguous memory. And so all the guys are stored contiguously in an array. All the monsters are stored contiguously in an array. And that means if you want to iterate over things by type, which we do often, that's pretty fast, right? Because they're all that good stuff about things being contiguous in memory. Okay, so, but we don't know what the entity types are. We don't know what the default values are for this. There's all these things that we use to, at runtime to do these operations. And we just say, well, we don't know what those are yet. And placeholder says this is going to get generated by the metaprogram. And this was another thing that we had to figure out because initially it was just there's this programmer idea that we have when something is powerful. Like, oh, this feature's so powerful, you could do anything with it. You could just add a string to your program later that just defines a bunch of stuff. And it's like, yes, but then when there's an error somewhere and I have an undefined variable somewhere in my program and it was going to be in that generated code, but I don't know that right now because I don't have a clear view of all the generated code, it could be really hard to debug that. And so this is a mechanism to make it clear, like if this never gets generated for some reason or whatever, the compiler will say this function tried to use num entity types, or this data structure tried to use num entity types. There's a placeholder for it here. So it's not just like undeclared variable. It's like, oh, this was supposed to get filled in by compile time execution, but it didn't, right? Okay, so that is going back to the metaprogram, gets filled out here. So num entity, where? I hope it's not in a different file. Again. Oh, you know what? I moved it. Okay. It used to be out in that metaprogram. But again, one of the many issues that we work through is, okay, there's a lot of cleanliness and structure and stuff that you gain by having a separate program like that. But also, it can make things harder to understand because one of the things that's hard to understand about larger code bases is when things depend on each other, but they're far away from each other in the code, and there's no explicit there's no explicit note telling you about the other thing or whatever. It's like, I have to spend time learning the system and understanding what are all these invisible constraints. And so I actually saw this earlier when we flipped past it, but we have this note called run when all typed. And that's just like that thing. This is the same kind of note as we use to register the commands and stuff. But what this says is this function to generate the entity code, I want it to be near the entity code and near the stuff that gets generated. I don't actually want this to be in a separate metaprogram, right? But you can't just run it off the rip because it depends on knowing all the entities and stuff. So we have to wait a while to run this. How do we know when to run it? Well, the metaprogram knows when to run it. And so this note here, run when all typed, if we go back to the metaprogram, when we see that, we add this to like hooks to run. And then for all the hooks to run, we actually add a run command back into the target program to run that thing. And so this gives you a way to factor these things back into the program, like I could have just said the following, like we said in that simple program where we ran print factorial, I could say run Sokoban emit here, but then this is going to run like whenever the compiler sees it. And no, we want to wait for all the entities to get compiled and make sure that we have them all and stuff. And so this is just a more sophisticated way to do that. Anyway, this is what generates all that stuff. And it used to be in the meta program, but as a part of evolving things and making them more convenient and more usable, we created this facility for factoring things back. But this is only, that's not even a convention of the programming language. That's only a convention of our own meta program. Whether that's something that takes off and other people end up doing, I don't know. But like, so this is creating all these variable declarations that you saw at the top of the file and filling in those placeholders with compile time generated data. And so as a result, you don't have to maintain anything, right? You just go, I can create a new entity and it'll be there. And that's great.
Can we do now a 10-minute break? Because I need to, a bit of emergency walk the dog.
Okay, I understand. Okay, people. 10-minute break.
10-minute break, and we come
I need
back
to figure out why my desktop is being so weird, but yeah. All right, I will make some more tea. Look at this. The tea is down very low now.
Oh, so that's emergency on both ends.
Yes.
So coming back in 10 minutes.
Let me go to the YouTube. Oh, do I want to read YouTube comments during the thing? No, not really.
I think there are lots of like good spirited comments. So,
okay.
So 10 minutes.
All right. Cool. I'm looking for Woocash podcast on Twitch. I'm going to stop the screen share. Maybe I should have shared my whole desktop. If we do more sharing after the break, I'll share the whole desktop. It just, I hadn't, I wasn't sure if there was like trade secrets on my desktop because I wasn't careful about that. Yeah, there are no trade secrets on my desktop as far as I can tell. Okay, what's the Woocash podcast? Let's go to, do we go to Twitch? Where should we go? I think it's on both, right? There's things called Woocash on Twitch that are not the Woocash podcast. Okay, I don't know. We won't figure. We'll take a break. We got to get the tea going if we're going to be ready in time. Okay, I found the Twitch channel, everybody. I am on the Twitch channel. How about a quick game of Fortune's Foundation? I don't want to abuse podcast time. Is that Golden Monkey Tea? Yes, it is. Yes, it is. 2,000 wins. Ah, you're ahead of me. I am at something like 1,843 wins. Demo of the interface feature. I don't know that it's that important of a feature. We could. I mean, we could demo all sorts of programming language stuff if we want. We'll see. We'll see how we want to spend the time. I mean, we've been going a long time already, right? I guess he ran the stream for an hour before we started, I guess. So we've been going 2 hours.
Okay, I'm back.
Hello. I've
Dog
got
diarrhea.
a refresh on the tea level. I didn't boil quite as much water as I should have. We could have had more, but it's fine.
But it's barely boiled, no? It barely has color. Is this expected?
Oh, well, it'll get a little darker soon, but you don't want it too... This is a very strong tea, and you don't want it too dark.
Okay.
Yeah.
All right. You've shown the metaprogramming capabilities for commands and entities now,
Yeah.
which I'm assuming I was trying to imagine how much code it would actually be to do those in C++ and how messy would it be to interface with like CMake and then add the new sources that are generated and stuff like that. And the convenience of using those features are awesome. Enjoy. In the language, sorry.
Sure, you can
The
call it whatever.
language.
Some of this was based on some of my experience early on. So at one point, I was an intern at Sun Microsystems when I was in college, when that was a thing. And they had some user interface builder back at that time that was like, everybody loved it because instead of just writing some code to create buttons and whatever, you could like drag the buttons into the right place. Yeah. And then you hit generate and it would generate some C++ code for that, right? But so once you do that, then, and that had its own little textual specification language for its own project file. And when you hit generate, it turns that into a thing. But then that led to these process, like I forget, I guess there was like this whole IDL thing that was spread through all the code then it was called interface definition language, right? And actually there were multiple versions of this. So I think it's kind of a generic term, but Sun had their own one. And it was a standard step in building programs there that like, there was a step that generated from the IDLE to the C code or C++ code, and then from the C++ code. And it not only made building slower, but there were all sorts of like, oh, I just got this file from source control and the timestamp was kind of wrong because it wrote the IDLE file like before the generated file. And so the IDLE file is actually newer, but it doesn't realize that, and so it's not going to build. And now my build mysteriously fails, and it takes me an hour to realize that the file was out of date. So like all that kind of stuff, it's just like, I just have all these memories from decades of pain, right? Because when you figure that out, it's so stupid. It's like, oh my God. And so when I design these features, I'm trying to solve these problems that I had, right? In a very reality-based way. So yeah, I mean, I don't want to have all this like generate. So part of the way that programmers nerd out, right, is they envision some really complicated system and they're just like, oh, it's so beautiful that this program passes this to this program and that does this thing and passes it to these 3 other places. And then there's 17 microservices that all rotate it and then blah, blah, blah. And it's like, no, because that's so many points of failure, right? And so many things like, okay, to program, you at least need to build your program to convert it into an executable form. So in some way, any complication that happens in building is something that literally every programmer has to deal with, but also even like understand. Like you have to spend time understanding all that machinery and how it works. And so you just don't want it to be complicated and full of all these failure cases, right? So like this is a little bit of a cynical way to say it, right? But like if you're gonna build a like you can't actually program in C quite, or let's say C++, because it's got more of a sometimes people do single file C programs, but like the culture of C++ is you have all these files in all these directories, and then some of the files are only on some operating systems and whatever. And so you can't, like C++ cannot define its own program. You need something like a makefile or a pre-make file or a GNU config file or like whatever. You need multiple programming languages as the cost of entry in order to program C++. If you use the makefile or whatever, CMake, whatever, that doesn't give you any kind of GUI to manipulate your thing. And so now you're going to redundantly have some GUI config file specification that says what's in the program and where, like Visual Studio does that, right? And so it's just kind of, it's way more complicated than it needs to be, right?
Or you have
so
more than one. You can have like CMake that generates the Visual Studio project. That was now the definition of how to compile real case scenario.
That's one way it goes. Or the other way it goes is you just have a bunch of different ones on different operating systems. So like, oh, we want to compile for iOS. So we have an Xcode project that defines the program, right? And we want to compile on Windows. So we have a Visual Studio project. And we want to compile on Linux. So we have a CMake project. And they're just all completely in parallel, which means they're always out of date, right? When you make changes and whatever. And you have to synchronize all those things. And it's just like, why have we made such a big mess out of the most basic things that everybody has to deal with, no matter what? And so I'm trying to simplify. And now this is one of these mildly controversial things, right? I'm going to tilt my camera a little. It's one of these mildly controversial things because the Unix philosophy, let's say, it hasn't actually turned out this way, but the idea is you have all these components and they're really simple and easy to understand, and you string them together to make programs like from the shell or whatever, right? And that probably kind of worked a little bit in 1970, but I think it's been shown to really not be a good way to make things, in part because now all those components are black boxes where it's a great amount of effort to mess with the source code and somehow manage to compile them and all that, right? It's not like, well, I mean, some of them are themselves shell scripts or whatever, but at some point the leaves that actually do the work are not shell scripts. But people look at that kind of design and say, look, it's so simple because all the components are simple. But well, actually a lot of like awk is not very simple and you're using that all over the place. But also you're only looking, you're taking this entire system of all this spaghetti and all these things, and you're only looking at the leaves and not even counting the number of leaves and saying they're simple. But like, to understand and deal with this system, you need to understand all the spaghetti that you just skipped, right? So, you know, and whereas on the other hand, if you do, like I would characterize this programming language as a little more of a monolithic design in the sense that it's taking all these responsibilities into the design of the language. It's like, look, you shouldn't have to learn 5 programming languages to compile your program. So we just take care of everything you need to compile your program. That does make it a little bit more complicated than if we didn't do those things. But on the other hand, it's way less complicated than if you're trying to do modern software engineering across all these platforms and all these things. And it can be way more powerful. And so that's the choice that we make. Now that said, you know, the thing that I think of in Unix land when I say that a lot of people are going to think of is the whole systemd thing, which I don't think that was the right, like that was a whole, like, let's take this system of init scripts and turn it into a big monolith. And like, I don't understand why you need a million lines of code to decide what programs to run at startup. Like that doesn't make any sense to me. So just, I think you need to delete all of that and start over, please. But for this, like a programming language is a place that you, as a programmer, you live inside that programming language all day, every day. So like some things really matter a lot. Like when things are bad, they're really aggravating, and they're kind of, you put all this effort into this thing that you're trying to make beautiful, like your own program, and like you're being stopped by like something about the system that you're trying to use, and like that really sucks. And so I'm just trying to be mindful of all this. So some languages, when you ask them why did you design these features in this way and whatever, they'll say, well, a lot of programmers are beginners or aren't that good or whatever, and so this feature is curtailed in this way so that you don't shoot yourself in the foot or whatever. And it's kind of a patronizing way to design. I mean, it is true. So look, even you don't have to get egotistical about like, oh, this programmer is better than this one or whatever, to just acknowledge that obviously when people are new to programming, they're less good, and then they gain experience and they get more good, right? So there's a curve of how good is anybody at any given time. And yes, especially because programming has been a growing field, there's always been more new people than experienced people. That may be changing soon, because we had this whole, oh my God, AI is going to delete all programming jobs in the next 3 days, right? Is what everybody says. But that is a reality, right? A lot of programmers are inexperienced, but I think it's a more nuanced way to design, to say, okay, look, we're going to try to have good error messages. We're going to try to have things that help you out when we're going to have good document. Like, why do these same people who say we curtailed all these features so that beginning programmers can have a better time, and then you try to go read about how anything works so you can learn the language, and it's the worst documentation you've ever seen, and it takes somebody to like write a third-party book that you have to go buy in the bookstore in order to actually learn the language. Like, it's ridiculous, right? So we actually try to do a better job with that too. Our documentation is incomplete, but what is there is meant to bring people up from near zero knowledge to being able to use the language, right? But also, like, you can be high dynamic range about this. You can say, look, we're going to talk about a feature now. This feature really isn't for beginners. So if you're a beginner, you could skip this part, come back to it later when you know more about what's going on. You can shoot yourself in the foot with this feature pretty badly. It's for experienced people, right? Like, you wouldn't say, like, if people are going to like build an office building, they have some really strong tools that most people don't need. They'll have like jackhammers and big like earth digger machines and whatever. And you don't. So first of all, I don't have a giant like earth digger machine in my yard because I don't need one, because I'm not in that line of work. So first of all, I don't have any weird complex. I don't act like, oh, I have self-esteem problems because I'm not good enough to use a big earth digger machine, right? That's not how it is. That's not what I do. It's like, I might mess around and like dig a little hole somewhere to put a plant in, but that doesn't mean I'm in the same line of work as those guys, right? First of all. Okay. But somehow in programming, it becomes a big ego thing. Like, oh, this is a tool for experienced programmers. Oh, you're saying I'm stupid, right? Like, no, it's just like, look, different people are doing different things. They require different levels of tooling to do their job. And that's not a surprise anywhere in the physical world, but somehow in programming, people freak out and they're like, you're not designing this for every programmer to use. And it's like, no, we're not actually. But that's so there is this design process that a lot of languages go through where it's like, it's some subset of design by committee where it's like design by committee for literally everybody. And therefore everything has to be not really a power tool anymore. Right. And I don't like that. Like, as someone who gets very deep into my own projects, I want to be able to have ways to solve problems. Yeah. So that's the mindset from which these features are designed.
I'm wondering what's gonna then happen. You kind of alluded to this earlier. How is the language you're making gonna look like after the release? You know, if because then like you can you know the story about like the languages that like hey they started out nicely. Even LLVM has the similar story, right? Like, and it was like designed by one person, coherent vision, like pushing this forward, and then the committee happens, and then everybody happens, and then like now we're designing for everybody by committee, and now it's like, oh, okay.
Yeah, I don't know. I mean, so on one end of the spectrum, let's say you release something and you successfully make it nice, which is hard, so you might not even succeed 100%, but you make it as nice as you can. And then you release it, and then that happens, right? It just gets turned into the same thing you were trying to avoid. At least you had that thing from some moment in time that other programmers saw, and that can propagate forward in time when they make things. Or like, oh, I saw an example of a thing that had certain set of properties and it wasn't encumbered in certain ways. I would like to do better than that, but it's hard because, like I'm saying, I kind of need to choose at some point where my time and energy goes. And I think, so you always have to look, we all have talents in more than one place, right? And so like, hey, I'm able to program, I'm able to design games. Which of those is a more unique contribution to the world that I have? And I do think that I have a relatively distinct way that I program that is different from a lot of people. But if I look at that versus game design, I'm like, my contribution is more unique in design. Like I have more of an individual voice there. And so maybe that's where the effort should go. Which doesn't mean I don't program, right? In fact, when I design by programming, right? But it's like, if I'm going to spend some number of work years, am I going to put it into the compiler or am I going to put it into the next games? I feel like the right answer is a little bit on the compiler, more on the games. Not that I'm a moron, but just more on the games.
But would you then solidify sort of the
well then
language?
So I have this problem to solve, right? Of how do you prevent things from reverting to the mean, right? Like I'm trying to make this thing that's not a mess. Even so down to simple things. So we've talked about all these features that are different from other languages and stuff, but there's even simpler stuff. So like that basic code that I showed, that's the equivalent of libc. It's like much simpler than anyone's libc, right? You can understand the code relatively easily. You can step into it and it makes sense while you're debugging your program and all that, which is not true for any C or C++ that I ever used. And so like even something simple like that, you can just imagine that decaying over time because people want to add this, they want to add that, they want to refactor this a certain way. And like, I don't know, maybe it's not really possible for those things to maintain. I'm not sure. But it's a problem that I want to try to solve to the greatest extent possible. I just don't know. So you could think of a few approaches. One is completely hands off, throw it over the wall onto GitHub and I'm done. And here you go, guys, right? That's not completely, that wouldn't be the complete story no matter what, for the following reason, because we're using this language in our future things. And like, so then we kind of have a choice. Are we running an internal build of the compiler that we just evolve separately from the public one? Or are we using the public one, right? Or is there some hybrid thing where we're re-importing changes from the public one, and then are we republishing those eventually? And like, so that's one layer of figure out what that is. And I don't know the answer right now, honestly. Another layer is organizationally, like, is there a benevolent dictator? If that's me, it's probably not me for a super long time. Cause like I said, I need to do games. And the thing about, so we have a beta program right now, right? It's got a decent number of people in it, but it doesn't have the whole world in it, right? And once you have the whole world in there, you're talking about like running well on like CPUs that you never heard of, right? And like whatever these issues are, right? There's use cases that you never heard of. And like, that's one of these things that drives this expansion and this like cluttering, but it's also one of the things that makes languages be used in the world. And like, it's one of the reasons for things to be open source, right? Is like, oh, this doesn't target my weird CPU that nobody ever heard of, but I can make that happen because I have the source code, right? In theory, that's why things are open source. And in a very small percentage of cases, that still happens, even though it almost never happens statistically. So I mean, somebody has to deal with all of, like, okay, all these change requests are coming in. What do we accept? What aligns with the direction that we want this language to go? And for what do we say, well, that's just your local branch that you need to deal with? And, you know, I don't want that to be me, honestly, also because I just don't like doing that. I want to work in a clean system that I had control over, and where I can do, you know, so these decisions about like, how are we going to architect the meta programming and all this stuff, I can make these decisions mostly in the absence of friction, right? We do have a little friction, like I said, from the beta group, but it's not that bad. And everyone in there most people in there are pretty cool. Once in a while we get someone crazy, but that happens when you have 1,000 people. We've only had to ban like 2 people, I think, so far out of 1,000. That's not that bad for the modern internet when everyone's on serotonin uptake inhibitors.
So do you foresee the situation when you're acting as a benevolent dictator for some time and you have like an apprentice that is sort of like near you and like learns how to do it, and at some point takes over?
I mean, we already have people who work on the compiler as well. So Raphael, who people in the beta know, has done a really decent amount of internal stuff on the compiler, and he understands it better than anyone but me. And so you could expand. We have 1 or 2 other people who've like touched the compiler a little, but like not done serious contributions in a while. So you could imagine doing that. How well does that work? I don't know. My personal experience is that I've been pretty disappointed on the game side when I try to bring people on who are relatively not experienced in it and try to coach them up to how to do a good job. Like, it's weird. Like, people don't seem to listen ever. They're just going to do what they're going to do, and you can give them all the advice in the world and they won't follow it, and then you just have to rewrite their code 2 years later anyway, and you just paid money to employ them and it didn't help. That's, you know, I'm categorizing a certain category of person. We've hired lots of programmers that did good jobs, so I'm not saying anything about that, but I'm just saying this idea that you bring somebody on to learn the system and then they're going to be able to take over, it requires a certain kind of person in the first place. And maybe that person's kind of hard to find, right? So there's some degree of luck involved as well. So I don't know, man. Like I said, it's something we got to figure out. And obviously after the game ships, this becomes a much more presently relevant issue. Right now, it's like something in the future, but next year, after the game ships, it's like, okay, this is the next thing that we're doing is, you know, releasing this in public. I will say there's 1 or 2 more features that I kind of want to make better before we do that. Like, relatively decent. I mean, I think most of the major features in the language are fine. The macro system still isn't as good as I would have wanted it to be, and it's kind of complicated and causes a lot of implementation problems in the compiler. Like, so we have this hygiene. There's still some code in the compiler that's wrong, because in the early days, if you have a variable declaration, then whether it belongs to a particular function or data structure or whatever, was just what is the scope the variable was declared in. And even if you have like an anonymous struct inside a struct, it belongs to the anonymous struct and it just gets a little link importing the name into the parent struct or whatever. But then you have hygienic macros and that's not true anymore. And when I first implemented those, I was like, oh, it's going to be pretty simple. But there both was all this older code that's like, oh, we understand where a variable is defined, where a variable is stored by what scope it's in. And then even to this day, like source code, by the way things are written in the source code, it can make clear what's important to understand and what's not important to understand. Like the names of variables, where the variables are stored and all that. To this day, we have a variable called enclosing scope on the declaration that points at the place where it is registered, but like there is no separate equivalent variable for like where I am stored that's in any clear way. And so that could be a refactoring of the compiler just to make that fact clear and understand. But because it's sort of swept under the rug that way, I also mentally sweep it under the rug because I go back, you know, I'll spend some time working on the game instead of the compiler's not as fresh as in my mind anymore. I go back to work on the compiler and I'll just like, oh yeah, we need to do this and that. Okay, what's the enclosing scope, and do it. And I just sort of don't take the issue as seriously. And then some bug report comes up a month later. It's like, oh yeah, oh God. But the macro system is not as powerful as I would like. Like we use it in basic ways in our game and all this stuff. And it's very useful, I would say, in certain specific use cases. Like if you want to inject some code and maybe some variables because like, oh, like I've got a profiler and I want to have a little thing that looks like a function call that will put some code into the local scope or whatever. Aside from that use case, I don't use a ton of macros though, because like in C land, the historic use of macros a lot of the time was just like, I want to make sure this thing gets inlined, right? And in modern compilers, it's not really an issue because they inline way more stuff than you necessarily would want anyway. But also we have guaranteed inline. And so you just say inline, you don't need to do that. The other thing that you would use macros for historically in C is stuff that syntactically is not valid in the base language, right? Because you're just pasting together strings and whatever. And I made the explicit decision not to do that because there's a couple things about that. One is that it's just a place where certain kinds of messes happen in C. It makes code hard to understand when people do a lot of that. It makes it very hard to debug because macros are not in the real target language, and so your debugger doesn't know what to do with them. And it's the worst thing in C when like you need to step into some code and you're like, oh, this thing is calling a bunch of huge macros. You just have to like guess at that point. So that's terrible. And then also it introduces, like the type def in C, it introduces an order of compilation dependency, right? So in C, there's this thing, it's the classic thing about C grammar where the grammar has to like change a little bit, like the way it's parsing things has to change a little bit based on whether something's a type or not, right? So in this language, we don't have that. You can tell if something's a type or not from where it's written. And so that type might not get defined until like 3 files later when you're compiling, and you don't need a type declaration telling you it's a type before you can parse it like you do in C, right? Macros are like that too. Like if you have a macro, it has to be declared before the thing that uses it. Otherwise, you can't make sense out of what it is. Or C macros, right? And by extension, C++. And so I wanted to avoid that kind of a thing, just as a basic, like, how does this language work and what happens and all that. If you want to reintroduce that, of course, your metaprogram can run a preprocessor, right? And that's fine. But like in the base vanilla language that we give to everybody, how does it work? And I wanted to avoid that kind of thing. And so as a result, our macro system operates on parsed data that is not yet type checked. But so it operates on syntax trees, which part of the thesis was that'll be really powerful because you could do like Lisp and like mess around with things and whatever. But part of the reason people did that in Lisp is because all the data structures were that way anyway. They were just like all trees and stuff. And so whatever. You don't really want to store stuff in trees if you can help it. I mean, that's more like the data side, right? But then when you look at code, you don't want the data structure for your code to be all these like binary trees. You want it to be more defined structs like you define in C or C++, where there's a lot of members in the struct because they're stored contiguously, but also it's just easier to understand. Like, look, here's all the stuff about this declaration, like here's the type and here's the expression it's bound to, and here's any modifiers that are syntactically, like all that information is in one place, as opposed to like I have to follow a bunch of links to get that information, right? And so all the information that both that we send to the meta program, but also that the macro deals with, is that kind of a thing. And it's also strongly typed as opposed to like Lisp, right? And so all these differences mean maybe you just don't do that kind of a thing, that kind of rewrite in the same way. And so that's the one feature from the language that hasn't totally landed. Like my picture would have been that by now you would have macros that take code as arguments, and they very easily do a bunch of rewrites on the code and whatever. And the reality is we do have macros that take code as arguments and do rewrites, but it tends to be a kind of involved thing with a bunch of code that runs at compile time. And the good thing about that, though, is it's a lot more understandable than Lisp macros because it's just regular code that you can read and it makes sense. And it's got variable names that are longer than one letter and like whatever. But it also, it's just not as carefree and, you know, simple to deploy as I would like. And so that's the big question for me with the macros is like, is there something to do there? And releasing before we answer that question is questionable, right? Because then again, if we change the way macros work, everybody has to whatever. So we'll see. But that for me is the one major unresolved semantic question. I mean, also though, there is a lot to be said for like, look, this is just version 1 of the language and we could fork a version 2 and just make breaking changes from there and it's not that big of a deal. I don't know. You know, we can start naming it after the year, like with C.
Exactly. Like every 3 years you have another release.
Yeah.
I have a couple of closing questions about the game.
Sure.
Did you disclose the platforms? The order of
so what
Sinking
we
Star?
said in the trailer is please wishlist the game on Steam. It is called Order of the Sinking Star. Wishlists don't cost you anything. They're free, but they let Gabe. So Gabe is on his yacht in New Zealand and he has a little screen that a little line comes up every time somebody wishlists a game. And so if Gabe sees that happen a lot for a game, he'll be like, he'll call Jay and say, Jay, please give this game good placement on the store. Right. And so that is why. So when you wishlist it, it makes sure that on launch day, people actually get the game as a suggestion. So we said that at the end of the trailer as well, because the trailer premiered in the Game Awards, which is a very big audience. They released the statistic yesterday or something that there were 171 million live streams, which doesn't count all the YouTube views and all this, right? Now, because the nature of statistics is you want them to be high, that's probably not people who watch the whole show. That maybe counts people who watched 1 minute of the show. But what we're in there, it's a 4-hour show and we're 90 seconds of the 4-hour show, right? So whatever. But it's a large audience, and so we want to make sure people know about that. We do want to come to other platforms as well. Like traditionally, our games have launched on consoles as well. We're still figuring that out. We don't have anything super specific to announce, but it is likely that we will come to consoles in some way. And when we have very concrete things to announce there, we will announce them. But yeah, so certainly, you know, in terms of the programming language and the game as well, there's nothing that like restricts it to Windows, you know. There's a little bit, actually one of the ergonomic things that we're trying to do in the language. One of the, I won't say what it is, but there's a feature that C++ has that C didn't have. Maybe it has it now, I don't know. And the C++ version kind of sucks. So we didn't have this feature at all. And it makes it just a little bit more difficult to deploy on weird operating systems like Android or whatever than you otherwise would. And we want to make that totally ergonomic and streamlined. But yeah, I mean, you know, we are able to compile executables for different consoles and all this stuff, and people in the beta do as well. And so it's just really where and when does it make sense for us to launch the game is the question.
Okay. Now, you mentioned a couple of times that the engine is there to stay. And it seems like it's very like Sokoban oriented engine.
Yeah.
Does that mean that like the next games or possible games will be around the same area, or is it just like the Jai core engine will there to stay, but it will need to undergo some changes to fit the new game?
So here's what I would say is this question also comes into play. I mean, for anyone who wants to think about, because we're going to open source this engine, you'll be able to compile it and run it. And it's like a guy walking around in a Sokoban room, and you're like, but I want to make a first person game where you walk around and take photos or something. I want to make a totally different game. And it's like, well, the engine we're going to release it's not trying to completely be Unity or Unreal. So it won't just magically do other genres of game. It would require a programmer to do that, right? However, a lot of the really hard parts of an engine are agnostic to the genre of the game. So like all the stuff that interfaces with the GPU, defines the data structures of like what is a mesh, right? How do you send a mesh to the GPU? How do you change the parameters of what's getting sent to the shader, right? Even like the editor, even like a lot of what's in that editor, some of it is at this point tailored toward like, well, a lot of gameplay objects are one thing in a square, but you saw me zoom the camera around a little, and like, that's not that different from what you would do in a first person game. And so a lot of it is like redeployable for other genres, but because we're not in the engine business, we're not trying to sell an engine, we're not going to be doing that. So we're not competing with Tim Sweeney or anybody like that right now. It's just the goal. Okay, here's what I would say philosophically, right? Is there are people who are trying to compete with Tim Sweeney. There's Unity game engine. There's the Godot game engine, or I've seen people pronounce that in various ways. So those are all of them have some certain kind of philosophy behind them, which is they're essentially GUI based creation engines. And then, you could kind of program a little bit to make your game, but like the programmer is not central in those, I would say, right? Like if you're going to write some GD script or whatever, like it's not that hard to do. People who are not professional programmers could do it, and you could ship a game, right? And if you're going to go edit the engine code, you like could, but like not a lot of people actually do that. They make more like ancillary systems on the side. So this is going to be more like a programmer centric thing where it's like, we want to make a game. We want to have a starting point that's like professional quality. But we're willing to do a lot of the changes, moving things around, deleting things, whatever. It's going to be more like that. And so it has a different philosophical approach than these off-the-shelf engines. And that also means it won't be appropriate for nearly as many people, right? So like the user base of this thing that we're going to release is probably not going to be as high as the user base of any of these other things that we mentioned. But for the people who want the kind of thing that we release, it's going to be pretty cool. Now, in terms of our own use, because that was where you started the question, it so happened. So the next games after this are not Sokoban games. They're not even puzzle games, mostly. But they do have a little bit in common in terms of the kinds of characters and scenes and whatever. So you could imagine, like a Diablo style game has this sort of overhead camera view, and you run around and fight monsters in an action way, right? So you can imagine it's that kind of thing where there's some crossover with what we're doing right now. So like the view in this game that we saw is very different from like the view in The Witness, which is like first person looking around, right? And so there's some overlap, I will say. And a lot of the art techniques that we spent all this time figuring out will also make sense in the new games. If we stick to the roadmap, which I don't, we haven't really started on any of these next things, so anything can change.
Did I hear correctly? Not a puzzle game?
Not a puzzle game. So we actually have there's 3 different games that are either in some prototype state or, well, 2 of them are in a prototype state. One of them is has never been implemented at all, but is sort of a natural follow-up from this game or some other stuff. And the 2 that are actually in prototype state are not puzzle games. The third one would have puzzle elements, but would be very different from anything that we're doing now.
Okay.
So who knows? Who can
It's
predict the future?
Super vague, super
Yes.
secret.
Yes. It's the way we like it.
All right then. I feel like we're reaching the end.
Okay.
I think we should mention that the Order of the Sinking Star is available on Steam for wish lists.
Yes.
And if there's not a spike after this podcast, I will have angry Jonathan Blow discussing this afterwards. We're like,
No, we won't have
how's
that.
this
But like,
possible?
look, you want Gabe to notice you. You want Senpai notice me for Gabe N, and that will happen if you click the button. That's all. He sees every wish list. It's like Santa Claus. He sees.
He might
knows.
even send you email personally if you wish list. He might.
Well, actually,
So-
I mean, that was the whole thing. Was you could email Gabe, and he would just read it and reply. I don't know if that's still true, because maybe once he said that, he got bombarded. But maybe, like, there's definitely lore on the internet where people screenshot that Gabe replied.
But on the Valve website, you can look at the contact, and then you like scroll through the list of employees, and it's like everybody's email address, like Valve email address.
Yeah.
So you can still do it. I don't know.
Anyway,
I don't know who-
so if you wish list the game on there, there's other ways that you could find out about it. There's a Twitter, I think it's Sinking Star Game. You could search for it. You can follow that. There's a Discord channel if you like to waste time on social media. I tried to retweet the Discord channel the other day, and like Twitter rewrote the link, and then it wasn't opening Discord correctly anymore. And that didn't work. So I'll try to retweet it. And if we can get computers to function correctly, I will tweet that. You can also find me personally on Twitter as well. Unfortunately, I still spend a little too much time on that website reading trash.
What do you do? What do you do to seclude yourself from like notifications and social media?
Well, I mostly don't. So, so Twitter is at least like, I never would have notifications turned on for something like that. So I only see that stuff when I explicitly go to it. Right. And so that's my general. So we have a Slack for the company, right? I'm not on there because I don't want messages popping up all the time. So I mostly respond via email, and email again is like you go to the email and you see the email. If you're not going to the email, you're not bothered by it. And that's everything. So, messaging apps on my phone, I mean, I have like 4 because you have to, but none of them have notifications on. And you just only open them when you feel like it. And so then you're at least not having your focus derailed all the time. You still have to deal with this other thing of like, I'm kind of mentally fidgeting because I don't want to focus right now. So I'm going to go distract myself. And I do that a little too much probably, but I still get work done. So it's okay.
Okay, there's been like for the past 4 hours of the stream, like hundreds of questions. What's the email address for Jai Beta? And I don't like. Okay, I
so if you personally put people in the beta still, I would love to have a helper for this, but I don't want to put it in an open form. I mean, you can find it. We still haven't changed it. Too many people email it. You can find it, but like, so, Soding, I don't know how to pronounce his name, but he did some streams where he was using it, right? And like, just those streams were, very popular, and just there were tons of emails that came in, and it's great to have that kind of attention, but it's also like, oh God, I'm getting emailed by I have real work to do, and I'm getting emailed by all these people wanting to get in the compiler beta. And it is, so the reality is like, it's obviously good to have people in the beta, but like, because we only have a limited number of people in the beta, it helps us focus and, you know, just not be dragged down by this like dealing with community all the time and stuff. And so we're just trying to walk a really thin line there. So, you know, it's not a judgment of anybody's like, you know, again, you know, it's not an insult or a judgment to someone's personal value if we don't answer your email. It's just like sometimes we get too many emails and we just, you know, that's really a thing is like sometimes when we're not getting that many emails, it's like, oh yeah, we could add these people, no problem. And sometimes it's like, you just have to make a really good case if you email during those times. But also, you know, I try to, you know, there's some amount of overhead per person that you deal with. And while taking on that overhead, you want to maximize how well do you test the language? How well do you make sure it works in different contexts on different systems for different people? And so we try to add people who are really actively going to use it for real problems and real problems that we maybe don't have as much coverage for, right, through other beta users. Is there some algorithm there or some heuristic? People use the word algorithm all the time when they mean heuristic. And I just did that because I've been corrupted by the casual language of the people. There is some heuristic there. Yeah, I mean, we get a lot of emails that say, hey, I have 2 weeks to mess around with this between homework assignments. And I'm just like, that's not who we're looking for in the beta right now, just because it's not efficient in terms of amount of test of the language versus overhead, right? So, but if you really want to figure out where to email, you can find it. It's out there.
Okay, that's gonna be the lead. For one last question, super last question. You played Blueprints. What are your thoughts on Blueprints?
I don't want to. So the problem is, if I comment about, there's multiple frames of mind I could be in when answering questions like this. If I'm a designer, every single game I play, there's things I liked about it and things I don't like about it, right? And I could comment on those. And the problem is, anytime I do that, somebody makes clips of me saying the negative part and not the positive part and massively overemphasizing the negative part and posting that on YouTube for rage clicks. And then everybody thinks I'm an asshole, including people like frickin' Fabian Giesen, who people in this community know. Like, he got mad at me one day on Twitter. This was years ago, but he was like, "You're such a negative person." And I'm like, no, you're just seeing the selective like things that people are amplifying. And like, it just like when it starts to affect your real world relationships, it's really poisonous at that point. Sorry. I shouldn't have brought him into this, but like, that's what it came into my mind. Apologies. Okay. He's a cool guy, I'm sure.
Episode
but
with
we had this
releases next Saturday, like tomorrow.
What releases?
In 2 days. So I had discussion with him.
Oh,
and
okay.
Actually releases on Saturday.
Yeah, he's a smart, very technically knowledgeable guy, so I'm sure that's a good. How many hours was that one?
3 hours plus.
Okay, standard length. Okay, the point being, also just because I'm known in indie games, like indie game developers especially, like freak out about any comment that I make. Again, partially using it for rage bait, but partially just like we need, in this era of the internet where it's so easy to see what people say, you just have to understand that people are people and they have opinions, and it's not the end of the world if their opinion is not the same as your opinion. So I'm not going to say any opinions about any games is the upshot. But I do think, so Blueprints is nice in many ways. One of them is it really shows that even in 2025, when things are really like so many games get released on Steam, a lot of them like not that much effort went into, obviously, right? That's true on consoles as well. It used to be harder to get on consoles. Now there's like, you know, shovelware on consoles sometimes. I think maybe they started to cut down on it, but it's been a problem. And so how do you stand out? And so Blueprints is a 2025 example. Animal Well, I think, came out last year or something, but it's another example of people who had a vision for something they wanted to make. That vision involves careful craftsmanship over the experience, good presentation, but also having something interesting to present through the good presentation, and just like working hard on the aspects of the programming. How does it feel to be in the thing and all that? And they put a bunch of work in, and then people responded. They were like, "Oh, this is a really good thing," and it's very heartening to know that you can still do that, because some places it's not necessarily true. Like, have I heard about games on iOS that work that way? No, I don't think that I have. Does that mean there aren't any? Well, I don't know, but I kind of think there aren't any, right? Because that market is set up in a different way, such that like you buy users and you get on the top list and whatever. But for whatever reason, it's still possible on PC and console to like have a thing that's simultaneously your passion project, but like sometimes people say passion project in a dismissive way, like, oh, it's not what you do for a living and get paid for. It's like your but no, but just like something that you really care about and that you worked hard on, and that's different from everything else. And the fact that that still works is great. And Blueprints is an especially interesting one. So Animal Well is kind of a Metroid game, and that's a genre that like people understand, right? But Blueprints isn't even in a genre. I mean, it's sort of like kind of like a game that you might play with friends around a table a little bit, with like placing cards and stuff, but not even, it doesn't fit into anything exactly, right? And so if you asked people a year ago, what's the game that you're going to want to play most in, let's imagine what you wanted to play in 2025 and tell me what you would just be really happy to play. And literally zero of those people would have described Blueprints, because it doesn't fit into any preconceived pattern. And yet it was made, it comes out. Actually, that's not quite true, because there was a Blueprints demo last year, I think, if I remember correctly. But ignoring that fact, right? That's still part of the magic of probably all creative fields, but especially games, is like you can give people something that they didn't know that they wanted and be very successful that way. And they will appreciate that, because it's like, oh yeah, I didn't predict that this thing would be what I wanted to play, but I really want to play this thing. And that's great. And that's also how we expand the overall manifold of what video games do, right? So I don't think there's a subgenre of games yet that's called the Blueprints like, right? Because it's too early, but you could imagine that happening now, right? Because it's anytime there's a very successful game, people are like, I'm gonna do that game, but there's monsters in the hallway that follow you, or whatever, right? And so we'll see over the next few years if that becomes a genre, but I wouldn't be that surprised if it does. Yeah.
All
Is that a good enough answer? Did I dodge the question while not dodging the question?
I feel like, yes, you made like you very, very like around it, but also like positive. Not.
I mean, to not dodge.
Sure
I think it's a good game, obviously, and it does a really interesting. It does one of the things that people really like, which is when there's a lot of hidden things about a game that you can discover and figure out.
Yes.
I do think that there are some things that are a little rough about the design, but for a first-time designer, that's not surprising at all. And it's amazing as a first-time designer to come out with a game this sophisticated, actually. So, yeah. But I do, if I designed Blueprints, I would have made some different decisions in some places, but we're not going to give the Rage Farm clickbaiters any fuel.
All right. Perfect. Jonathan Blow, Order of the Sinking Star, available on Steam for wish lists. For everybody live in the audience, thank you for joining and showing up.
Thank you, everybody.
Submitting questions. Jonathan, please stay so that the recording's going to get uploaded.
Yep. All right.
Closing the stream.
Bye.